title of our this webinar is operations technology, and these days this word has becoming more popular uh, in general in the industry. Probably the intention was to differentiate like information technology and operation technology, but we try to keep it simple in a manner where all these terms actually are centering around the same thing, that how are we talking about in general the industrial control systems environment, and especially because this group what we have, we all come from a process safety management type of a background. So we keep this definition clear, that you will be interchangeably hearing different words like operations, technology, some call it industrial control system, cybersecurity. But the way in future the standards, they want to make it consistent and uniform. They want to use and promote probably the word like automation control system. So that encompasses many things, and that is what we'll try to do that. Although I fully understand that this word has not yet really got traction, but then from the perspective of what we will be covering is the industrial control system, automation control systems, what we talk about. So what typically which we can come across and relate to as industrial control systems is what is shown on this slide, just to get kind of a warm up and get into what we will be talking about when we say about ICS cybersecurity or OT cybersecurity. So we are basically talking about variety of the systems what you probably would have encountered, not necessarily as a being in the industry. Not all of these would be there, but just to give you the flavor that how the automation cybersecurity could relate to each one of this. So we talk about, let's start from the rightmost top, that DCS. Most of the plants, by some or the other means, whether oil and gas or chemical, petrochemical, these days, they have the distributed control system as the main basic process control system, which is definitely widely used, and we'll talk about on each one of them how they relate it in terms of the risk which they bring in. Metering systems, again, it's not necessarily fiscal allocation planning. You may have all of that coming under the umbrella of automation control systems. You have turbo machinery control systems. Again, a big component of that comes from the power industry or within the oil and gas industry, which is extensively used. You have anti-surge control systems, which are again important aspect of automation control systems, which are dedicated for the centrifugal machines, anti-surge control, yet they carry the cyber aspects of it very much within them, and we'll talk about that. Machine monitoring systems, which comes under the umbrella of vibration, axial displacement, both in terms of the safety and the monitoring, which also happens for the performance monitoring and the other functions. PLC, again, a big component of the automation control systems when we say, and we can't avoid including that, because there is a large footprint of automation control systems which leverage this particular device, PLC, very versatile, and again, because of that versatility, brings in different dimensions of security, which we will talk about. Then we talk about the fire and gas systems and the associated, you can say, the emergency shutdown systems, HIPs, and all of that, the safety systems, which I'm sure you would appreciate more than anybody else, coming in from a process safety management background. So this is basically setting the tone that what we are going to be really talking today, and how these systems probably have some or the other type of vulnerabilities which we need to understand and consider that how we can protect it. So moving on, from an operation technology definition, what we can consider is.
Sorry to interrupt. I think the statement was a bit, but if you can just retry to keep the control.
Yeah, I think it was, because I was trying to. It toggled probably. Yeah, thanks, Abhishek. Yeah, so the first slide gave you an overall understanding about in terms of the various systems probably which we can relate to when we talk about automation control systems. And this slide will set the foundation in terms of having better visibility about what all we cover under the so-called umbrella of this operation technology or automation control system cybersecurity. So if you look at it, we tried to put it into kind of a, three levels or layers, you can say, as L1, L2, L3, and we'll take a deep dive as we go into the presentation. But what essentially it means is that we are covering what we call as the embedded devices, which are they are faceless in the sense they are not the computers, but they are dedicated, purpose-built embedded controllers running, say, DCS controller or a safety controller or a Bentley Nevada, what we call the vibration monitoring module. So all of these are what we call as the embedded devices. And those are not running any Microsoft Windows or anything like that. They are purpose built with a firmware, but then they do have the cybersecurity aspect of it, and definitely they become the foundation or L1 device of the so-called Purdue model, which will take deeper understanding as we talk about. So this is the first level. The second one, where we typically come across you as the users or the people who come into the control room and then they see all the HMIs, operator workstation, engineering workstations, or all of that, which are man-machine interface with the background, some server or a computer which does this dedicated function of providing that type of visibility to the process or for carrying out the engineering and so on. So all of these generally are having some sort of the OS, and the most largely used, of course, we talk about is the Microsoft Windows operating system base, but yet there are other flavors also, whether you talk about the Linux or in some cases some of the open source as well. So those are what we call as the level 2 network. And then on top of that, as we all see that many of the plants these days, they have applications which are whether advanced applications like advanced process control, alarm management, historian, or the loop tuning and so on and so forth. So again, this also forms part of what we call application level, and they come again within the purview of what we call as the OT cybersecurity scope, which is addressed by the standards and all that. So what doesn't come in that is basically the field sensors and actuators and all that what we are talking about. Those are not part of this, but the scope is essentially this. And then we are not talked about the 3.5. We'll talk again later, which is your DMZ zone and all that. But from the basic understanding about what is OT comprising of is basically gets covered with this understanding about L1, L2, L3, and the way you can relate it in terms of your real world. You see the PLC, you relate it. Oh, this is a L1 device. You see the operator station, you talk about okay, this is L2 device which is running on a Microsoft Windows platform and so on. So this is just to get you started with it, so that when we approach the subsequent slides, we have the clarity about what is being visualized under the so-called this operation technology. So taking again a little bit deeper understanding of that, so let's talk about the typical hardware, software and protocols which form the essential components of whatever we just talked about in the previous slide. So if you consider from an hardware perspective, you're talking about the industrial controllers, as we say, PLCs and DCS and all that. Of course, the field devices we talked about, they are not part of it. The human machine interface, HMIs and engineering servers. The software, again, which is a very important aspect of it when we have to look at it, the vulnerabilities and other things. And also because they are essential component. You can't run these systems without the software which goes with that. So you talk about various software. So whether it is a control system software, which is invariably purpose built for that particular application, then you are talking about engineering tools and programming environments, which is also very important when we look at the risk associated with that. And then the visualization software in terms of the graphics and other things, which is essential for the view to the plant for the operators and all that. Again, they also have some sort of visualization software. Historians, they run on their software, asset management systems, all of this. So software is again important aspect which we have to take into account when we have to understand what are the risks which particular this OT system poses. Not poses, but from the external environment, what that particular product or a software, the vulnerabilities, how we address it and all that. Then the third important aspect of it is also the protocols. Because we talked about the hardware, we talked about the software, but how they communicate. Again, that is very essential from the aspect of cybersecurity, because those protocols, depending on the type of protocol we use, they carry certain exposures, because not all of these are built with a frame of mind of a cybersecurity. And we have to consider that many of these protocols have been used in the industry for a pretty long time. And at that time, there was no consideration for building a system which is having this cybersecurity in mind. So we have to look at what type of protocols are in use and what are the security exposures each of these ones bring in, including the first one, what we have mentioned about the OEM proprietary legacy protocols. So we will again, as we said, this is an introduction. We'll talk more about it as we go on. But you would understand now, so we are going to talk about the cybersecurity in terms of its hardware, in terms of its software, and the protocols for the communication, what it carries. So what are the characteristics of operations technology? So let's talk about that again, so that we are having clarity about it, that how that would probably differentiate from other information technology systems, cybersecurity when we talk about, right? So all the operation technology systems, what we talk about, automation control systems, as you can see, they are meant, the primary purpose of that is in terms of monitoring or controlling the physical process in real time. So that is the key point which really differentiates, and that is why the whole treatment and management of this drastically changes compared to the IT systems, although some of the components of it are still the same. So naturally, being controlling the physical processes, the focus lies on the safety, reliability, availability. We all come from the industrial background and we know the importance of each one of them, what they carry. And that is why the focus has to be on the topmost is, of course, the safety and availability of the system. Then the other point, which is again very important, we need to keep it in mind, is that as we know, all our plants, they run for so many years, and the control systems which actually run those plants, also because of that, they have a very long lifespans. So they are not the one like, we run for a couple of years and then, so the lifespan again makes the operation technology systems quite different than the one what we see in the non-OT environment or a information technology environment. So what that translates into is the next point, which is the updates. So when you think of your home PC or a one in your organization managed by the IT, you invariably see, like on a everyday basis or a every week basis, you see some or the other patch has been installed and it asks you to go and restart the machine, or it automatically does also in so many cases, because that's how it has been scheduled. So the updates also make a big distinguishing factor between the way we can patch or update those systems, or the ones what are in the industrial environment, in the operations environment, where such type of things cannot be done with the same type of frequency. And the last but not the least is, of course, the criticality. So as we see in the first slide, you have all those systems and you can relate to that how the criticality of all those systems means to the plant and to the plant manager in terms of securing its production or safety or monitoring and all that. So this is what is the characteristics, I would say, of the OT systems, which we have to keep it in mind, which is having some or the other dimension when we talk about the cybersecurity aspect of it. Then the industries, what we are going to come across. And practically, as you could see, that all these systems, what we talked about so far, are there in every industry, whether you're talking about the paint or a petrochemical or a power or whatever it is. So you're talking about really the OT cybersecurity impacting from the manufacturing plants, with the assembly lines which are managed through the PLCs, to the energy sector, we talk about the power generation, distribution, you name it, oil and gas, water treatment, continuous process plants. So all the so-called process industries and other things, whatever we can talk about, come under the umbrella of so-called this definition of, because automation control systems are there everywhere, including the one what we talked about also on the from a transport perspective, when you talk about the automation what goes into those transportation systems. So the envelope is pretty large, where it is you're talking about number of different industries where such type of operation technology systems are being used. Each one of them will have a different perspective or effect from a risk consideration, and those we will again consider it as we go further into this presentation. So the big question is that nobody was talking about so much about the cybersecurity. Yeah, then everybody started talking about the IT cybersecurity because so many phishing scams or other things are going on. But of late, you must have come across there is quite a bit of talk going on in terms of the OT cybersecurity. OT, why we did not talk about before, and why suddenly are we really exaggerating certain things, or why we should talk about it, is what we'll talk about in this slide. So if you talk about it, previously, like when I started my career from 1989, when probably the first DCS came in, nobody had talked about it. So, in fact, recently when I had gone to my alma mater, which is College of Engineering, Pune, I had the privilege of talking to the students, and I told them that when I passed out in 80s, late 80s, probably I never thought that I would be talking about the cyber security in the profession what I am in. And one of the big reasons for that is this adoption of COTS, right? So what is COTS is commercially off the shelf. So previously, if you remember, some of you who had seen the older generation DCS, they used to be the boxes with operator station and all purpose built and proprietary hardware, software, and all that. And if you look at the today's DCS, you see the vast difference. All of this is running on the Microsoft Windows servers, and also the switches and other things which goes on. They are also being utilizing the one which is available into the information technology domain. You're talking about the Cisco switches or other ones. Yes, there could be some add-on firmware to that, which is making it specifically purpose-built. But in general, the big aspect of it, why we talk about the OT cybersecurity, because it is increasing use of or increasing adoption of what is available onto the information technology domain. You try to basically use that for various reasons, including the commercial aspect of it in terms of keeping the cost down. So that is one key aspect of why suddenly there is more focus on it, because yes, you need to consider we are using all those components which are also being used in the information technology industry, many of them. Second one is that if you look at it, the type of integrations of the systems which is happening now and what probably was happening about 20, 30 years ago, there is a big difference, right? So because of the pressures in terms of the keeping the cost down, performance enhancement, so many things, and of course the efficiency, business efficiency and so on, you see the widely the systems are getting integrated. So when you talk about the standalone system with the ones which we have today, where we are compelled to do so for various aspects of it, is causing the risk surface to expand. So you are talking about one system to the other one, they are interconnected, they are sitting on some large network where various systems are interacting with each other and all that. So that is bringing another important aspect which makes the cybersecurity even more relevant and something which needs to be really looked at, because the systems are getting highly connected. The third one is that, which is kind of coming in deriving from that, because the type of devices which you are adopting from the commercially off the shelf and the type of things which are also being produced within even the environment where we talk about like the embedded controllers and all that, which are also purpose built, but because of the enhancements and technologies which are being put together in that, we see there are number of vulnerabilities are increasing overall. So vulnerabilities and all we will talk again and take the deep dive, but you just consider vulnerabilities as we simply relate. It's a weakness in the system, right? You may call it sometimes as a software bug or whatever it is. So because of all these things, there is also the increase in the number of vulnerabilities because of various adoptions of these technologies and codes and all that. So since you have vulnerabilities, you must consider what are the impacts of that and how you mitigate it. So that is another aspect, that why the cybersecurity we are talking about now and not so much before, maybe about 10 years, 15 years earlier. The last one, what we need to consider is also the continued use of unsecured protocols. So this is, in my opinion, again, a very important aspect, because like we talked about, the legacy systems are gone, but still a lot of legacy protocols continue to be there in use. And that is why those protocols still they are not been completely phased out with the ones which are, are inherently designed as a secure protocol. So you still have those protocols in which are in use, which are not encrypted, they're not secured. People can actually really see all the data, what is going on, if they really have the intention of doing so. So the continuous utilization of those so-called unsecured protocols also makes it relevant with the three other dimensions which are in place, because you have to consider that when you have something insecure and you have all these other combination of factors, you are actually increasing the risk of whatever can happen because of those vulnerabilities and because of the proliferation of other aspects of it. So that is why probably we have this seminar and there is a greater awareness what is happening in the industry in terms of not just the IT systems, but how do I secure my operations technology or my automation control systems, because they carry a lot bigger risk than what my IT systems would carry, right? So that is why we are talking. So now we take a little deeper dive as I just introduced to you in my first slide. So how this, I picked up here, not all of them, but some of them, so that again, it gives us an understanding that, okay, what is this system and how do I relate that in terms of the cyber security, why I should consider about it. So again, SCADA is one of the system which is being widely used in, where we are talking about the grids, the distribution system, pipeline control, and so on and so forth. And again, in terms of the function, as we all know that they have been used for, centralized monitoring and so on. And they carry certain unique features where they are distributed across a wide area. And sometimes those are also not secured and all that. So if you look at it from a cyber security perspective, the wide area surface itself is, increasing the risk of that. Besides, the utilization of the so-called, we talked about encrypted communication and so on. And I think you must have seen some of the attacks which have happened on such type of installations, because inherently some of these protocols which have been in use are not secured. So this is SCADA. The DCS, I think, is most important. Definitely, we cannot ignore that, because that forms probably the largest footprint of any organization within the, the process industry. So we all know the DCS plays the part of the basic process control, and of course, some of the interlocks and other things which are non-safety critical also are managed by DCS. So although they are having high redundancy and the reliability factor is very high, from a risk perception, the redundancy, the security aspect of it really are not always addressed by just by having the redundancy. So that is the reason why in the risk we have to consider that the DCS, being the main basic process control system, would greatly contribute if there are any cyber incidents, because it will impact the production downtime greatly and directly. Why the risk considerations again are very important for the DCS? Because again, DCS being the basic process control, it has got probably the highest number of interface connections to the other systems and all that. So whenever you talk about the system interfaces, that means you are talking about expanded risk surface, right? So that makes it even more challenging in terms of, looking at all of that aspect and to see that how the DCS can be secured properly while allowing this. You can't say, no, I do not want to have any interface. No, you have a business requirement. You have to integrate the systems, but the question is in terms of how do I keep my distributed control system secure? So again, some of them, they carry, as I mentioned, legacy protocols. They have a very complex architecture, again, as I mentioned, because of the overall interconnections, what it could have, right from your process control network connections to the safety systems or to the external world. Sometimes you have some interfaces going on to the regulatory systems for the monitoring, to the electrical suppliers, again, because they have been mandated, or to your IT systems, because you want to monitor your, like they say, historians. So there are various reasons. Because of that, the DCS architecture gets complex day by day as the newer projects comes in, and they are built with more functionality for everything, including the remote monitoring or whatever. So all of that will have to be considered in terms of what type of risk it would pose. PLCs we talked about, again, the big number of PLCs are in use everywhere, whether you talk about the package systems or you talk about the automation of the automobile industry, manufacturing industry heavily relies upon the PLC. And because of the way these systems were being used, you commonly come across very weak controls in terms of how you access those systems. So weak authentication, and we'll take again the deep dive on that. But because of those risk considerations, these systems are also quite prone, because they are not been for decades probably the PLCs were not been secured from that aspect, because nobody earlier thought about having this cyber aspects of it. But the increasing interactions, the interactions or interconnections of the systems for these PLCs, including widely use of the remote connections by the OEM and all that. So all they bring in their own contribution of increasing the surface risk surface for these systems. Machine monitoring system, again we all know that vibration monitoring, axial displacement are very important also from the safety aspect, besides the asset management aspect of it, what we consider. And these systems also are having interconnections and so on. So bringing again the aspects of network security and all that into consideration, and which can have a direct impact again on the safety of it, because that the vibration and displacement in many of the plants, they are not merely the monitoring, but you have the critical safety interlocks also on that. Anti-surge control systems, again, many of the plants, like if you look at it in LNG trains where they are there and all that, where you have got huge anti-surge control systems, and they also have their own man-machine interface and all those type of HMIs. They all again communicate with the DCS, so they are not many of the time standalone. So all of that really brings in again a lot of cyber security, network security risk, which makes them quite important, because anti-surge is again one thing where any kind of compromise of such type of systems, you all can understand, being the process safety management background, they bring in you need to have a similar focus as what you give it for your safety systems, because of probable potential consequences of a compromise what these systems can pose. Metering systems, you have allocation, or you have the fiscal pay meters and all that. So not as much as from the safety aspects of it, but you can relate that if these systems are compromised and you have certain mismeasurements introduced, it could have a very big impact to the reputation of the suppliers, whoever is supplying, whatever the industry you may be, whether you're talking about the gas or liquid metering or whatever. But when you talk about hacking some of these systems, because again, many of these systems these days are networked, they are not just standalone, and they are connected to other systems. That brings in again, the same aspects of it, what we covered before, that it is increasing the risk surface. So from the considerations about the risk, the integrity of the measurement is very critical here from a cyber risk perspective, and also the customer and a reputational impact, what it could mean. If something goes wrong with these meters, then you're talking about loss of reputation, which is directly impacting your customer satisfaction. Also, many of these systems, like you will see it in the greenhouse emissions monitoring and all that, these systems are also networked, and if you have a compromise on that, there could be consequence from a regulatory requirements, because all of these systems are monitored, including some of the systems, although not really part of the conventional fiscal monitoring and all that, but they have these aspects which needs to be again considered when we do the risk assessment of that. We all know, I think most of the plants, they do have analyzer systems, and as we look at the bigger, the plants like the refineries and all that, the analyzer systems are also getting kind of integrated. They have their own networks and so on and so forth. So not all of the places, but many places these days, especially for the bigger industries, bigger petrochemical plants, you see the analyzers are getting networked. In some cases also the continuous emission monitoring systems are networked, which also have a kind of external interface to the authorities for the continuous monitoring and all that. So whenever we talk about this type of external interfaces or remote monitoring and so on, you need to consider that all of this directly translates into increasing the risk because you are connecting the systems, you are networking the systems. So because of that, all of the cases, we need to be mindful about how we design those systems, how we do the risk assessment of systems, and keep the system secure. So the risk consideration in terms of, we talked about calibration, data integrity, statutory, regulatory compliance. And why that? Because both the cases, I mean, you're talking about the external interfaces or the remote interfaces by the vendor, because many of the times these vendors, they uh, log in to these systems because of course, the cost impact of it, because they are sitting somewhere else and they try to access those systems in order to do certain batching or whatever it is. And they bring in, if those remote interfaces are not being properly managed, definitely you are going to have the risk exposure coming in because of not having secured remote communications. We'll talk about that when we go into the vulnerabilities associated with these systems. From a safety aspect, I think all of you know that how important the fire and gas systems are. And even though many of those systems might be kept as standalone, in today's networked environment, especially again for the large projects and large installations, these systems are also networked and they are connected to the other systems, or there is networking within the fire and gas systems to peer-to-peer communications and so on and so forth. So again, having the similar type of consideration as what we talked about for the other systems. You have here also the embedded controllers, you have got the man-machine interface, you have got the networking. All of that again makes the fire and gas systems and the safety systems one of the, what you call, very attractive proposition for the hackers or whoever wants to cause intentional harm. These systems pose a big threat because they can bring in, a direct, because of the unavailability of systems, will cascade into a major, potential safety-related incidents because these systems are hacked or they are not available on demand. So we'll talk about that more as we continue with this presentation. But definitely, compromise of these systems needs to be looked at it very carefully, and we need to build the controls in terms of mitigating those risks. Continuation of fire and gas systems is of course the safety systems, and just for the simplicity, we are putting it together, all what we can consider as emergency shutdown, HIP systems and so on. So all of this, again, you have to realize that some of the HIP systems, yes, they still have solid state electronics, but some of them they are not. But in general, I mean, we need to look at it from a safety systems perspective. They are one of the most important aspects when we do the risk assessments in terms of the way they are connected. Even though many of the times we call these systems are air gap, but in reality, we'll have to really look at it whether they are truly air gap. Yes, some of the solid state HIP systems, they are completely air gap. There is absolutely no network connection. Whatever it has is hardwired connections, you can say 4 to 20 or digital. But from the perspective of our cybersecurity risk assessments, we need to be very, very careful about how we design these systems, because somewhere we have taken within the HAZOP that yes, I have got the safety system in place, which is considered as independent protection layer, IPL, whether it in your SIL studies or whatever it is. So we'll talk more into the safety systems a little bit later. But from a cyber perspective, if these systems are compromised, then no matter what you have considered in your HAZOP, that I have built a safety function which is SIL 2 rated, I'm having a safety controller which is TV certified for SIL 3 or whatever it is. Because of the cyber security risk, all of that did not be available on demand. And that is the main reason why we have to do the type of cyber security reviews and risk assessments very thoroughly, especially for these systems, because the compromise of these systems, we know what it can bring about when those systems which are built with the safety in mind to protect it on demand, if they are not going to be available. So the safety systems definitely are one of the important aspects when we talk about the cyber security, and we'll take some more closer look at it in the slides, coming slides. Turbo machinery control systems, again, as you probably know, that they also are equally critical, because these are the machines which are heavily being used for the gas turbines and all that. And you know the usage of these gas turbines in the industries, whether you talk about the power, you talk about LNG, compression, whatever it is. So all of that are quite critical. And again, being the automation control system, they carry the same type of risk as what we have been talking so far. What is more challenging here again is that they are quite complex because of vendor specific systems. There are also many of the systems which are remotely monitored by the OEMs, and again, because of that, we need to be considerate about what the risk they carry when we talk about this remote on-site monitoring, which typically is being in use for such type of systems. And because if we think of any compromise, what type of repercussion, consequences it could have, besides just the downtime. We are talking again here about the SHE related risk which such type of systems, if they are compromised, will bring in. So at the end of the day, I mean, just to sum up, the OT systems not only have got a economic impact, because if you think about bringing the DCS down, yes, your production is going to get down because the plant is down. The big thing is about the safety, health and environment, because many of these automation control systems are directly involved into protecting the plant or process safety, whether it is an emergency shutdown system or whatever fire and gas systems, what we talk about. So they could lead to a loss of containment type of scenarios if they are compromised intentionally. And of course, because of that, it will not only be the sheer risk, but cascaded down to the environmental and the financial loss. Last but not the least, you have to remember that, and you have seen it in the recent, the past, where the cybersecurity, OT cybersecurity was compromised in some of the cyber warfare, what happened, and which really impacts the critical infrastructure of the nation, whoever is at, the war. And they can bring in, more serious consequences at that point of time in terms of bringing the energy systems or the power grid systems and other things down. And we have seen it. So you can relate that, because again, those are the OT systems which were being compromised and which are like critical infrastructure of that nation, and bringing in, huge amount of catastrophic failures in the nation. So I know we are at 11:15, but we'll just finish this chapter and then we'll take a break, if you could allow me. So to sum it up, I mean, here we talk about the differences. So the IT systems, as we all know, the confidentiality is the most important priority, whereas for us, we need to keep systems running. So we are operating our plants 24/7, and we want all of these systems to be running all the time. So the availability makes the big difference in terms of the way we treat these systems, even though the same type of hardware could be there. in both IT as well as OT. And here are the, just to sum it up, that what are the differences we are talking about. So we talk about the primary goal, as we say that the availability is the topmost priority, integrity, followed by that is confidentiality. The focus is, of course, on the physical systems, physical processes. Uptime requirements are critical. IT systems, yes, we need it, but it's not as much. They will tell you that, okay, I need to do the patch, and we'll say, okay, go ahead and do it. That's not the case when we talk about the OT systems. The lifespan is a big differentiator again, that as you know that in most of the organization, all these IT system laptops, you are changing quite frequently, but that's not the case with the OT system. You have a larger, longer lifespan. Change management, so frequent updates, agile approach. You see your IT guys are pushing every day or every week. That's not the case in OT. We can't consider having so much frequent updates. Performance priority, as we say, it's a 24/7. So the performance, deterministic performance is the essence in our industry, which is not the case here. You may have the latency issues throughput, yes, but those could be manageable, but not in our industry. And last but not the least is, of course, the risk tolerance. We have extremely low risk tolerance because of the consequences, what we talked about, besides the production impact, which itself is a huge thing. So we'll start with the next section. So we talked about why OT cybersecurity and other things in the first part, which all systems we actually have to take care of when we talk about operation technology, and so many things we talked about differences between IT, OT and all that. So in this section, we'll talk more about how do we manage this cybersecurity. What type of management program or cybersecurity program we should have so that we can take care of that. So the key aspects of it is basically you can consider like three major considerations what the OT cybersecurity program must have. And the first one, it starts from the one from the left side, the behavioral and technical competencies and security culture. So I think since most of you are from process safety management, there is a strong focus on the safety, and the similar kind of a culture when we have it at organization, which is a safety driven culture, we must also promote a cyber security culture within the organization, both from the IT as well as from the OT side. So typically we see now that IT culture is kind of gaining, but equally important is also the cyber security or OT cyber security culture at the plant, which needs to be really looked at it, because we see so many plants still having lack of understanding in terms of displaying the passwords and other things, which we often see in many sites. So the reason for that is really going into the cultural aspects of it, that how the organization is looking at the cybersecurity when it comes to the OT technology or at the plant control systems. So bringing that behavioral change is very important, not just for the purpose of understanding, but also to realize that all of these personnel who are interacting with the systems, they are also kind of protection layers in terms of helping the asset owner in terms of making the systems more resilient, robust, and all that. So from that aspect across the organization, whether we talk about from operators to the engineers who are working on these systems, and the other systems which also are kind of some of the times being supported by some other discipline engineers like rotating equipment, process engineering, whatever it is. So overall across the organization, the management should promote a behavioral, technical, both competencies to look at the cybersecurity. And we'll talk some of them more as we see. But the technical competencies are in terms of the people who are actually securing those systems. They need to be really have that competence, and which is really a big thing because the way the technology is changing, and now even with the introduction of AI within the the operations environment, it is going to be a tremendous learning curve all the time in terms of how we take care of technical competencies of the people who manage those systems. The other important aspect of it is, of course, like any other program, would have its own policies and procedures and all that. So, on the IT cybersecurity, we see a kind of good maturity in terms of organization having their security policies and all that. But not always the case when it comes to OT cybersecurity. Sometimes they try to leverage the information technology security policies, but then the focus, as we have seen, is completely different. So you manage this program also in a different way for a OT cybersecurity. So you can always leverage and make sure there are synergies, but definitely the consideration in terms of having a dedicated OT cybersecurity policies and procedures is really important. So can only these two things are good enough for securing the plant or securing the system? No. Naturally, you need to have a technology, but technology alone is not a good enough thing. So, yes, in order to secure the systems, you may install the firewall, you may install certain advanced protections, antivirus, whatever. So many controls are there which we'll talk about. But on its own, it is not going to serve the purpose if the cultural mindset is different within the organization. The cultural mindset is not in terms of sharing the password or not really understanding in terms of what are the risks and so on in terms of clicking certain things, even in the environment where we are not connected to the internet. So, behavioral technical competencies, cybersecurity program, all policies and procedures, and the technologies all put together need to be looked at it in order to secure our plant operations, secure our systems, and so on. So the two important statements which you see there are very important, and we'll talk later also about that. But secured by design and secure by default. So those are very important statements. So you need to design it considering secure by design. So that means you are inherently making as much as possible your design secure and also secured by default. Meaning what? That even if you have designed it, but you have not applied those type of configurations which are required by default in order to really provide that type of protection, it will not be of any use. So say for example, just to elaborate that secure by default point, you might have installed a firewall considering, yeah, I have a firewall and it is going to protect me. But if it is not been configured properly, if there is basic rules like deny all, so you deny basically all and just allow what is necessary in order to have that communication. So that is a good example where you can say that secure by default configurations have to be adopted so that you inherently build, design and build a system which is secure. The other statement is also very important is adoption of fit for purpose cybersecurity controls. Many of the times what we see is that there is exaggeration about the risk, what has been considered because of various things, including the marketing or the way the systems are projected. Or on the other hand, complete lack of awareness in terms of building the controls and so on and so forth. So what is essential is that we must look at the risk and then build fit for purpose controls which are both cost effective as well as operationally which are feasible. So these two aspects are very important for any cybersecurity program in order to be resilient yet effective in terms of the cost. How do we manage it? Now, for every such type of programs or standards or procedures, what we, you have, there are international standards which we take it, whether ASME or API or whatever, all of them, so many of them. So they are used as sometimes as a for guidance or sometimes as a compliance requirement or whatever it is. So when it comes to the OT cybersecurity or automation cybersecurity, the only one, the main one, of course, there are some which are industry specific, which are there in every country, every organization, and all that. But in general, as an international standard, if we look at it, the ISA and IEC now, whatever we call as a joint standards, which comes under the umbrella of 62443, they are the family of standards which really addresses all the OT cybersecurity aspects of it under various, you can say, buckets, I would say, in terms of, as you can see here in this slide, you talk about policies and procedures, you talk about the systems, you talk about the components, you talk about the evaluation criteria and so on. So I don't want to go into the details of it, but the 62443 family addresses and lays the foundation in terms of providing cybersecurity by all the entities or stakeholders. So whether it is an asset owner, whether it is your system integrator, whether it is your OEM who is designing the system, or the maintenance folks who are going to provide you the support. So these standards will address all the expectations for all these stakeholders and doing all the life cycle, you may say, of various activities which happen right from the initial field scope until the demolition. So 62443, you can keep it in mind, is the standard which is the standard which is used for the OT cybersecurity. Now the question comes in that when should I really start? Now everybody is talking about OT cybersecurity and OT cybersecurity, but what is it? When I should start, when I should end, and all that. So the answer for this is very simple, that we need to start it just the same way we do our engineering feed. And at that time, each of the disciplines, they have their feed package and so on and so forth. So right from the conceptualization of pre-feed work, the OT cybersecurity has to be embedded within that. So many times, especially until the maturity was not good enough, we have seen many plants which were built and then they went in for number of MOCs and other things right after the commissioning, because the important aspect of the cybersecurity design was missing. So we really do not want to have a situation where OT cybersecurity or automation cybersecurity was introduced later on, while all the field work is done, detail engineering has come, and now we start realizing, oh, but my system is not been designed like that. So we must embed the cybersecurity, experts right from the beginning to do the conceptual design, which is pre-feed activities, detail engineering activities, testing and commissioning activities. So all of that, if you can really see, they have some or the other dimension of it. So in the initial design, like what we will talk into the next slides, the cybersecurity architecture or a system architecture needs to be defined. What are the, just the same way that many of you have seen, we carry out the HAZOP and you do the SIL assessments and you design your safety systems with a safety requirement specification. So similar to that, you will have to come up with a security requirement specification and all that as part of the field engineering. Then as part of the testing again, that similar to the type of testing we do for the control automation systems, where we do the FAT, we do the SAT. Likewise, the cybersecurity controls which are designed, they need to be tested with a proper factory acceptance and site acceptance test procedures. So again, the full life cycle, as we talked about, covers all these different aspects which need to be considered at various phases of that project or the life cycle of that plant. Then of course comes the operations, that you have done the testing, you have commissioned the plant. During operations, are we going to just leave with that? Yeah, you have built a system, I have put the firewall and all that. No. There are sustainment activities which are very important in order to make sure that the controls which are designed are available when it is needed on demand, as what we call in the process safety side also. So operation sustainment activities again will take a little more deeper dive into the subsequent slide later on. But within operations, all of those activities have to be really taken care of. So sustainment and operations, these are the two ones being put there because there are certain aspects of it which is also related to the monitoring of that. So within the sustainment, again, you are monitoring these plants. Depending again, not all of them need to have the similar type of thing, but definitely based on the risk, similar to what the IT infrastructure has got, where they talk about the security operations center and all that. The bigger plants are now also embracing the similar type of concept for having 24/7 visibility of what is going on into the operations networks or systems. So the last one is of course the demolition, which is also equally important because you see not just during the demolition of the plant, but prior to that, when you are demolishing certain systems because of the upgrades of the systems which are very common in our industry, I mean the automation control systems. So the demolition of that system also has to be done properly because again you are talking about certain important proprietary data which is needs to be demolished or destructed in a proper manner. So you throw the system out, but then yes, how do you really have the procedures in order to do that destruction with a proper mitigating risk controls? So that is the reason that OT cyber security lifecycle covers entire thing, and at every point the cyber security focus has to be there in order to make sure we have robust cyber security posture. So how do we actually really have this delivered? If you really look at it, so all the stakeholders, what you can imagine, they have a role to play. Okay, so it's not just the question of asset owner, the guys who run the plant, but the ones who design it, the ones who implement it, the ones who do the verification, operations, all of them. So it's a shared responsibility, and that is what this is from the IC 62443 specification itself, that any one of these also not really appreciating and understanding their part could impact the cyber security. Because if you look at it, that I have done the plant, I have built, I have designed the plant, taken care in the field and all that, but then from an OEM perspective, when he delivers the system, if that security requirements as a OEM, which are again described in the 62443 4-1, that how you have a security development life cycle, they call it like SDLC. If they do not have that, again, then you have the gaps in terms of meeting overall expectations. So the shared responsibility model is very important in order to deliver a cyber secure system or the component or whatever we talk about, because it is everything has to be there in place. If I only see that asset owner is doing its part and the others are not really appreciating and delivering the systems based on these expectations, we could have problem. Vice versa, you may go and get the system which has got a 4-1 certification, which has got a 3-3 certification. This one is similar to what we call it, just to relate to you, that like you have a safety integrity level, we have it here security level. So if you think about a system which is having security level 2, but then the asset owner even doesn't have done his own part of having a policies and procedure, not conducting risk assessment, it is not of any use, because his part is equally important as an asset owner. There are expectations on him in terms of having the proper program, in terms of having security of the systems with basic controls, and of course other aspects of it in terms of doing the risk assessment, similar to what we do in AZOP and all that, do the periodic risk assessment. All of that only if everybody contributes in that way, with the shared responsibility model, what is being put here, then you can ensure that we are going to deliver a secure automation control system. And of course, because of that, secure plant operations. So this is what we talked about in terms of how do we manage it, in terms of the standards, what it has, what the program we should have, and what type of considerations in terms of the shared responsibility. Now we will talk about certain aspects of OT terminologies and concepts, so which are important, so that you have an overall understanding in terms of when you talk about OT cybersecurity. Okay, what are the important things we should think of? So this section would take a deep dive into that. So the first one is, of course, I'm sure you might have come across this within the organization, the Purdue model. So this used to be a very what you call very widely used word, where people used to say, I have to build a system with a Purdue model. So what is that? So we were talking in the initial first part where we talked about breaking that network into various levels. So as I mentioned to you, we had level 0, which is we talked about the field transmitters, sensors. I mentioned to you before level 1, which is your embedded devices. We talked about the DCS controller, we talked about the PLC, the RTUs, and all of these, like the embedded devices, what we call it, including, suppose if you're talking about the safety controller or the vibration monitoring system, the main processors. So all of that form part of the level 1. Level 2 we talked about again before, which was all the operator stations, engineering stations, which has got Windows operating system mainly, and the man-machine interface. Level 3 we talked about. Level 3.5 we will talk into the subsequent section as a slide, where we'll introduce the concept of DMZ, so which separates between your OT network and IT network. And of course, level 4 and 5 are your enterprise IT networks and external networks. It could be even an internet connection and all that. So from the perspective of a Purdue model, you can think of like level 0 to level 5 different networks hosting different type of devices. So this drawing will give you a better idea, because rather than talking about the words, it gives a better understanding in terms of the real world. So this is a typical one which I have tried to put it here just for the purpose of discussion. And here, as you see on the level 0, we are talking about the process, we are talking about the transmitters and valves and all that, actuators. And you consider here that we are trying to put level 1, but then we are talking about various systems which might be there. So, you are talking about the safety system, control system, process control. So we call it as different zones, because depending on the type of risk it has, we try to suppose group it. So just for the purpose of simple understanding, we are trying to put it into these different systems under different heads. But then if you look at it, those are the devices which are coming on their level 1 respectively for those ones. So for a safety systems, you have got safety controller, SISIO and all that. But then as you go further, each one of them, they have their own level 2 network, where you are talking about their operator stations or other things. And then you have to focus here your attention that how are we really connecting these networks. So you see here, they have added the firewalls. Okay. So this is one of the important aspect about what we call the network segmentation, which is quite a lot of importance in the OT, and not as much as like in the case of IT, because our environment, all these networks are physically separate. So why? Because the segregation of these networks is in terms of building the proper security around these systems. And then when you talk about connecting this system, say for example, the level 2 systems which are getting connected with a level 3, on which we have our historian or some other patch servers and all that, you can see that they are being connected through a firewall. So you must have heard the name firewall. So firewall is basically, you can consider as a network control point, you may have a firewall, or depending on again the type of risk, you may consider in some cases, we will see here, the data diode or whatever it is. But the main thing is that we must have a proper network control between these levels, so that we are trying to make the system more resilient to any kind of attacks because of the type of segregation and control what we bring in terms of controlling the communication on the network and between the networks. So if you see here, we have put the firewalls for each one of these particular zones so that they are connected, but that connected securely, and then you are minimizing the type of lateral movement what it could bring in case if there is any kind of attack and all that. So this was our level 3, and then here you see that you have introduced the concept of TMC. So now this is a typical architecture. In real life, maybe they do not have these type of two firewalls. People may have other network controls like a data diode, double data diode or a single data diode. Data diode meaning what? That only the data would be flowing from one direction. So say for example, all the data which is coming in from here has to go to the L4. Then in order to secure the system at its highest, probably you can say, the protection, you may consider having a data diode which will allow only unidirectional communication instead of a firewall. Now here, just for the purpose of our presentation, I had put firewall because those are the ones which are widely in use. But depending on the type of risk, if you look at it, many of the operators, the big oil and gas companies and all that, invariably you will find that the connection to their enterprise network goes through what is called data diode, so that they're completely cut off. Even if there is any compromise on their IT network, because of the unidirectional flow of the communication, nothing can come from top to the bottom. And even sometimes within our OT side also, depending on the type of, suppose if you are talking about the safety systems, I do not want to have communication from other side. So you may use sometimes those type of data diodes within the environment of OT, and not necessarily what we call perimeter protection when you are talking about the IT OT. So overall, if you see here, the Purdue model brings in certain basic requirements of segregation of the networks, segmentation of the networks, and a controlled flow through what we call network control points. Why do they require? In order to ultimately make sure that we have a very robust network security, and in case if there is any kind of a compromise, all what we have designed out will help in terms of localizing those malware or whatever, rather than getting distributed across the network. So idea of, if you look at it, zoning it out, is the similar type of systems which has got a similar risk profile, you try to put it into that type of a zone. So safety zone will be safety zone. The other zone, the process control zone, would be zone A, which is called the basic process control network zone. So those are the ones which will be essentially carrying the similar type of risk, and then the utilization of the network controls in order to connect it. So this is overall, you can say, a typical Purdue model, which I just wanted to introduce you for the concept understanding about what is network segregation, what is network segmentation, and what are the network control points, like the firewall or a data diode and all that, which are very, very important in terms of what we called earlier building secure by design. So if we do not have all of these aspects as part of the secure by design, then we are not building a system which is inherently secure. So what are the concepts? Just to summarize again, what I mentioned, segmentation. So you've seen that the networks are segregated, segmented. They are not a flat network. So you keep this term in mind, because again, we will utilize it in further slides. Many of the plants which we see today in many of the industries, whether in India or abroad and all that, you see they have not followed this concept of network segmentation. Okay, so you see that it's a flat network, which like most of the IT networks they have, and because of that, it definitely introduces to a lot of vulnerabilities, and of course expanding the risk surface because of the lateral movement what it allows. So control pathways, as I mentioned, is essential in order to have a restricted communication flows at the perimeter level, which we call it data flow between ACS or between ACS and ACS or between the business LAN and the automation control systems or a historian, whatever we talk about. So restricted communication, why it is required? Again, the same thing. We want to minimize the risk surface so that whatever residual risk is there we are considering is kind of contained within that. We have also seen in this that you are not having anything which is kind of a junction box, okay, where you are connecting everything together like a switch. You connected this, you connected that. So naturally having a kind of a multi-homing, what we call, or as a junction, will enormously expand the risk surface. So we definitely do not want to have that, but rather have the network which is properly segmented. Other important aspect of it, if you have seen in that diagram, we were nowhere having direct connectivity to the outside world or internet. So definitely there are many PLCs which we can see it. If we go into certain tools, they will be able to tell you that how many thousands of PLCs which you can find it on the internet. So even though we talk about all these things, there are many small units or whatever where you've seen their PLC controllers are actually connected to the internet, and there were certain incidences where those were being hacked, including the places in US and all that. You can find it that even though we have been talking about OT cybersecurity and all that, you will find a lot of installations where they have still taken external connections to the internet for various reasons, and which are completely insecure. So the last important thing to consider is, again, a keyword: trust boundaries and zones. So as we talked about, the way we design our systems, that we will build the zones of having the similar type of a security risk what are being considered, like safety systems. We'll group it as safety, and then we'll talk about the conduits or the controls, network controls, what we talk about, in order to achieve their trust boundaries and make that communication secure. So this is again important slide, because many times people ask this question that my system is not connected to the internet. So why are we talking about the cybersecurity? So probably that question has, this particular slide has got the answer for that. So if you look at it here, they have mentioned externally generated cyber attack, which is good. You may say that, okay, I have put, of course, I don't have the internet, but I have external connections, and I have put double firewall, or I have put a data diode and all that. So I don't have anything, so why bother? You still have to secure the systems, because you have all of these networks and you have all of these, what we talked about, L1, L2, L3, and you have the risk of internally generated attack. So secured interfacing, strong firewall and all that at DMZ is one thing, which is for the perimeter security. But within the environment, below that, when we talk about L1, L2, L3, you still have to consider and secure the systems, especially because you have got also the insider threat, you have got so many things which are going on within those networks, and all of that needs to be secured in order to make sure that overall the whole system as a whole is secured. So if I say that my perimeter security and my internet connections are not there, they are not good enough, we have to look at the overall, all the network interfaces, and make sure that cyber security is embedded in each one of them. So we have seen that architecture, the Purdue model architecture, which I have shown you, which was showing from L1, L2, L3, L4, 5, and showing you the firewalls and all that. So when we talk about the feed, or the pre-feed and all that, so this basic security design in terms of having the proper architecture review is very, very important. So the slide I put it basically in order to emphasize on the fact that similar to the PNIDs, which we utilize it for the purpose of doing HAZOP and all that, you go and check it out, what if analysis, whatever we do. Here also, we must do that type of exercise with a system architecture to make sure that what are the type of backdoor entries we have, what are the type of lateral movements we can have on the network, how each one of those systems are actually complying to the expectation of this network segmentation and the zones concept what have been brought by the IC 62443. So all of that is part of the automation control system architecture review, which is very essential aspect. Just the same way we do the review of the PNIDs and all that, the architectural review is of fundamental importance when we start preparing for the feed onwards and all that. So the design cannot really be built without having the proper risk assessment at that stage, which not just does the scenario based evaluation but also the system architecture review by the experts team. So the key takeaways from this, what we talk about the Purdue model and other things, is network segmentation is one of the key controls. Normally in IT, yes, they may be also having that, but they do not have so much of emphasis as what we have it, because our environment, as you have seen, with the type of architecture which spans from L1, L2, L3 is quite different than the type of IT systems what we have. So network segmentation is a very important control which we have to keep it in mind. Review of system architecture and how those systems have been connected, we talked about in the previous one, is very important. The last, which is important part of the same thing, is applying appropriate network control points commensurate with risk. That is the key sentence or word you can say. Why commensurate with risk? Because if you think of a plant site which has got an exposure to its L4, L5 systems sitting on the IT network for whatever reasons, and then you are talking about some sort of a zero-day vulnerability or a very states actor-based compromise which has happened. If you recall, in 2012 there were big IT system attacks which has happened onto some of the big names in the big industry players in oil and gas industry in the Middle East. So you can think of that those systems, IT systems, were definitely very robust. They have been designed very properly, but yet they were being attacked. And then if you consider that risk and those systems having connection with your OT systems, and the residual risk, if you think of it, because it has already something which has happened, which is huge. We are talking about tremendous amount of financial exposure, SHE exposure. So there, instead of putting a data diode, maybe as what it says, commensurate with risk, people will evaluate and put, even though it is an expensive proposition, to put a data diode. So why I'm bringing it is to just explain this concept that appropriate network control will mean they are risk based and not just like that you put it. Maybe in some cases, if the risk is not so much, you may not even put firewall, you may build some access control list within the functionality of switch. I'm just giving an example, not necessarily be the case, but it should be whatever we do has to be risk-based. So we talked about the Purdue model. We talked about the important aspect of OT segmentation and all that. The next in line is just to get, and again I think you all coming in from basically the process safety management background, you are not new to the risk and all that. So the concepts are again the same, but we are just trying to put it from the perspective of cybersecurity. So again, for all of you, this need not be told that, I mean, we talk about risk in terms of the consequence and probability. We all know that. We are only talking about the aspects from a cybersecurity perspective, which is again more or less has to be in line with the corporate risk matrix what every organization has. Now, there are a number of times we have seen that the OT risk management is done following certain templates of IT risk management. That should not be the case. The OT risk management must follow the same type of ramp what is being used for assessing the risk of the other plant facilities. So consequence categories, since we have, are essentially the same, being the OT systems. You are talking about the SHE, you are talking about financial, you are talking about reputational and statutory regulatory. Why we are adding also the statutory regulatory? Because in some of the countries, already this has becoming a statutory or regulatory requirement in terms of the expectations what an operator must have to run the facility. So because of that, this has also becoming a regulatory requirement in some countries and also in some industries also. Like even in India, certain things they mandated from a central electricity authority in terms of compliance to certain expectations by the stakeholders within the energy industry. The consequence identification, again, I mean, why we are bringing in here is because unless you identify the vulnerabilities, you will not be able to really appreciate what is the risk, what it has. So what we have to consider is, as we talked about before, in terms of the hardware, in terms of the software, in terms of the protocol, what all vulnerabilities we have to consider. We have to consider who are the potential threat actors who will be interested in basically utilizing or compromising those vulnerabilities, who wants to exploit them. So we need to look at that very carefully because that is a very dynamic thing. Both of these, unlike the rest of the risk assessments, what we do is very evolving because of the technology and because of the various considerations what it has. So like maybe in the early 2000 or something, we never have thought about having certain type of malware which could disrupt the power distribution and so on and so forth. So all of this is very dynamic, and the identification of that is why it has to be done not just once but periodically reviewed also. Then the biggest challenge, I would say, in terms of doing this risk evaluation in the case of OT cybersecurity is the probability determination. And we will talk about that a little later when we talk about the risk assessment and so on. But the guidelines for that again could be that some industry incidents, guidelines from the company risk matrix, because they also try to provide certain guidance. But at the moment, just keep it in mind that we are going to talk about this because this is one of the most important differentiator, I would say, when you do the risk assessments or you conduct SIL studies or any other type of those ones, which are, I would say, quite quantitative and quite visible and clear, unlike the case when we talk about the probability determination for a cybersecurity risk assessments. So essentially, we are talking about understanding of vulnerabilities, considering the consequences, which are again going to be the same as what we do for any other plant thing, and not following any kind of IT type of risk assessment treatment. And probability, which is a unique thing, which we will consider it. So taking now from here, the vulnerability. So vulnerability initially in the first slide itself, we mentioned that it's a weakness, right? We all know it's a weakness that weakness can be in anything. It can exist in the systems, processes, people, and it can remain there hidden without getting exploited. And it is only waiting for some threat actor basically to exploit it and cause harm. But the key point is that the vulnerabilities needs to be identified for each of the type of device or equipment or a software, hardware, whatever we have. So that is one of the important aspects when we have to consider the risk. We have to first start with what are the vulnerabilities and what are the vulnerabilities with each of the devices or softwares or protocols which are participating in our scope or whatever the system architecture or the system we are building. What are the common OT specific vulnerabilities? So we mentioned about the long life cycle spans of our systems, and along with that, then comes the thing which we inherit from that is legacy systems. So our systems are not always, up to date because of various aspects of it. They are sometimes even unsupported. So all of that, what it means is that whatever vulnerabilities are there will not get addressed. They will remain unpatched. So that means you carry the risk exposure all the time because of not really addressing those vulnerabilities. So this is one of the big things. Second one we talked about earlier also, just reminding that there are insecure industrial protocols which bring a lot of vulnerabilities. The third important thing is weak authentication and access control. So you would have seen how many guys, earlier in the plant, when the days of DCS are originally there, and there used to be key, there is one operator, supervisor, engineer, so many people would have their key. There was no accountability, nothing. There is no authentication at all in terms of doing anything. So weak authentication is something what we have inherited. Now, of course, it is getting changed, but still there are a lot of shared passwords, common, accounts and so on. So authentication and access control is again a very important thing because that is a primary control which you must have in terms of having the access restricted. The last one is again, we have talked about the flat network architectures which are still prevalent, and that those themselves bring in a lot of vulnerabilities. So access control with authentication, and along with that logical access control, giving a lot of access to the system. So for example, I am an engineer, I am not supposed to have certain access at my level, and it is not been customized to meet my job role. So that also we will talk about, which we will mention about it in the other slides as part of the role-based access and all that. So legacy systems, the one what we talked about, long lifespans, designed for reliability and not cyber security. That is why they will be running fine, but then from a cyber security perspective, if they are not protected, you have a limited vendor support and patch availability is also limited. Outdated operating systems, yes, we see that. Recently, I had gone to one site for the gap assessment. I could see Windows 95 still in use. So you see many assets still having very old systems, high cost and operational risk associated with upgrades, which prevents it, unpatched firmware, software components. We'll talk about the vulnerability management in a while in the afternoon. But many of the systems, because there is no such program as vulnerability management, the firmwares are also being there as what they were being supplied, and no upgrades have been carried out in terms of whatever the security flaws which have been identified. Many plants inherit whatever the default credential the vendor has given, so maybe the manager or password, all of those ones still remain there. So which is also one of the biggest problems of those systems. They are not being changed. In some cases, there is a problem also that you can't change it. That is why it is written default credentials. So they were kind of hard coded, and you had no other option but to just inherit that. And then the last one is weak authentication mechanisms and poor access control, which was we talked about. So bottom line is that all of this, what we talked about above, the unpatched system and supportless system and all that, so they bring in the risk in terms of various things that they provide. In some cases, the entry points for the attackers, they exploit certain vulnerability. You can escalate certain privileges because those vulnerabilities are linked to that, and gain unauthorized access to cause harm. Flat networks, we had mentioned before also when we reviewed that Purdy model. All of the networks you can see in the plants which were earlier built prior to the this concept of segmentation and other thing came in. They had built it sometimes without even having a proper segregation between IT and OT, and especially you can see that in many of the manufacturing units, the automobile lines or packaging and so many industries where you have PLCs, you have other automation systems which are coexisting on the same network as IT systems, which is not just physically segmented, but they are again on a flat network, so which really brings in a lot of risk. PLCs, HMI, engineering workstation, again, as what we have seen, they were never having that type of a concept of segmentation. So they were all there put on the same network. Lack of firewalls or security zones, insecure remote access pathways into the control. So we talked about vendors these days requiring access to the systems for various reasons, for remote support, again cost optimization, again in terms of some crisis you need the support or whatever it is. But again, those flat networks with this remote connectivity multiply the risk, allows the easy lateral movement across the system. So something has gone, and then it would spread quickly to the entire facility because of such type of flat networks. Protocols, again, we had mentioned before, but we take a little bit deeper dive here, that there are some of the protocols we have mentioned here, Modbus, DNP, OPC Classic. So they did not have any kind of a security. Many of them are still there. Some of the newer versions of that which has come, which are secured. So they don't have built-in authentication mechanism. They carry the commands in transmitted in clear text. You will be surprised that some of the early identification of certain vulnerabilities when we did, and some of the proprietary vendor protocols, when we could see that the entire communication which goes on is so transparent, and you are able to see all the parameters, whatever you are of interest to see very easily, because even though the systems have been upgraded and all that, but the underlying protocols has still remained largely unchanged and which are not secure. So they are very transparent, and that is the reason why certain systems like this intrusion detection and all that can actually utilize that in order to identify if someone is gaining access. But it's a dual-edged sword, you can say, that because the communication in the first place itself is not encrypted, you are able to gain such type of tools. Modbus, there is no authentication, so much widely used. DNP3, clear text, just some examples we are giving. OPC Classic, DCOM exposure risk. These are some specific risks to the some of the widely used protocols what we can talk about. Access control, weak authentication, we talked about. Default shared passwords, many organizations still you find that hard-coded. We just talked about that some of the legacy systems, they have got certain hard-coded credentials which you can't change it. Still, many plants do not have the multi-factor authentication in order to make the access control robust, and we have to think of that in terms of systems which has got a shield consequences, safety, health, and environment. How we can make this access control more rigid, We have a couple of slides later on to talk about that. Excessive user privileges. This is what I was trying to explain in the previous one. So what happens is that you as a user, you have to be given the privileges both on an application and also on your Windows machine just to meet your job role. So say for example that you are an engineer working on the system and you have no business in order to install a new software or something like that, or for an operator for that matter, and you have kept all those privileges open for he or she, which is not really required as per his job role. So XSL user privileges are there configured because the organization has not implemented what we call role-based access. So that means providing the privileges which are just good enough for your role. So that inherently kind of trims your privileges, and because of that, the risk what you bring in because of that, because you have been given everything, so you could cause more harm because of the additional privileges which are really not required, either accidentally or deliberately, which can be exploited. The last one is again very important because unlike the IT systems, in the OT systems previously, because the security aspect was not at all being there, so very little logging and monitoring is considered in those systems in terms of, if something goes wrong, then not having the properly configured security logs or whatever the logs in a bigger organization where those logs can be monitored centrally, or the policies which can be looked at it in terms of if some compromise happened and which policies were kind of compromised, so such type of basic cybersecurity logging configuration is many times seen lacking, and all of that ultimately kind of promotes unauthorized users can gain access and cause harm. So underlying risk of access control not being robust is unauthorized access, which is really not required by the asset owner. So again, continuation of the vulnerabilities, this is some examples again what we talked about, which are put it in the way like what we talked about, software configuration and network, similar to what we talked about before in terms of hardware protocols and all that. So software vulnerabilities, many times we come across some issues related to the buffer overflows of the PLC firmware or the RT or something like that. So when you have such type of vulnerabilities, it can just lead to a what you call denial of service, because the device will not work. So those vulnerabilities again have to be looked at it. If those can be exploited by the hackers or the people who want to cause harm. Command injection in HMI, these are again some of the other vulnerabilities which are can be exploited in the environment. We do not want to go into all of that, but those are the ones what you see there are the exploitable vulnerabilities which needs to be tracked and addressed. Configuration vulnerabilities, on the other hand, we talked about secure by default earlier, and those are the ones which are in line with that. So default passwords unchanged, weak encryption settings, unnecessarily services enabled, missing access control, excessive. So some of the configuration vulnerabilities what we are talking about, you can think of it as hardening of the system, and again we have a slide after that, but in general what you have to consider is that we have leveraged a IT computer for doing something which is a very purpose built thing, like an operator station or an engineering station and all that. So all what we are talking about here and additional stuff what can be considered as hardening of the system, so that you remove all what is unnecessary for that particular system, which has to be purpose built. My role is not to provide you a computer, my role is to provide you an operator station or engineering station. So remove all of that things what has not been going to be used and which would unnecessarily cause increasing my risk, because those things have been there and which are exploitable, they have their vulnerabilities and so on. So configuration vulnerabilities, the system hardening is one of the most important one, that you take care of all that by hardening the system as a, you can say as a keyword, bigger word. Under that, so many things you will do in order to remove unwanted stuff and keep the stuff what is necessary for the functionality what it is going to deliver as part of the OT, service. Network vulnerabilities, we talked about segmentation, we talked about missing firewall rules. As I mentioned, you might have got the firewall, but it's not been properly configured. Is it of any use? No. That means it is the same thing, that it won't be available on demand. On demand, it will not restrict some communication, but it will allow unencrypted communication, internet exposure. Wireless, we have not talked so much about, but wireless networks also bring in their own vulnerabilities. It is very clear. But again, the use of wireless in the context of OT again needs to be looked at it from a risk assessment perspective. What type of wireless, where it is being used, and so on and so forth. But again, from a network perspective, both wired and wireless controls, they bring in their own set of vulnerabilities which needs to be identified as part of the risk assessment. These are some real world things what we have seen here from some of the product manufacturers. You can see that, and there is a score here what they call as a CV score, which is like a ranking, that higher the one, that means more the dangerous it is in terms of tracking those vulnerabilities. But what is important is that we cannot just go simply by the score and do the thing. So what needs to be done is that we have to look at what are the risks which it brings, that particular identified vulnerability in our environment. So that is a very specific to your site, and that needs to be done very in a customized manner. And you cannot just go and say that it is 9.8, so it is going to be really extremely critical for me. No, and we will talk about that in our vulnerability management slides, which will come there. So the key thing is we need to basically identify what are those vulnerabilities by having certain coordination, some process in terms of tracking it, and then understanding that what is possibly going to be impact of that if it is exploited. So we talked about initially about the vulnerabilities. Now we talk about the threat. Threat we all know is events and circumstances that exploit the vulnerabilities. So we all know that, but just to again have that clarity of thought that the threat, vulnerability without the threat is of nothing. So the threat actors needs to be identified who are going to be really utilizing those vulnerabilities and how they can utilize it. It can be intentional or unintentional. So both ways we'll have to look at it. What are the common OT threats? So external attackers, state actors, that's a big thing, especially when the stakes are high. You have seen it in the recent past also, the state actors which were involved in causing certain very targeted attacks. And some of them we'll talk about also in the case studies which we take it. So those are the state actors which have got very advanced tools in terms of, gaining the access or trying to basically exploit. Insiders, again, there is a risk that act of sabotage or malicious intent. Third party and supply chain, which is again a big thing. Something can go or injected right at the very source. This has happened in some of the software manufacturers of the companies which are themselves involved into cybersecurity solutions also. So their own supply chain sometimes is getting compromised. You have seen certain things which has happened on Microsoft also. So third party and supply chain is a very big risk which needs to be managed from the OT threat perspective. Accidental human errors, again, the threat actors are not really intended to cause harm, but unintentionally they can also cause harm. Various examples are there, including certain things which they may do it by doing configuration of firewall, there is a mistake, or doing certain patching. All of that also are the threat actors, but those are accidental, not intentional. And last but not the least is, of course, the software and firmware flaws which we have been talking about. Those needs to be really looked at it. You will be surprised to see that many of these ones keep bringing, because of the way the whole evolution of all this technology happens, and the more the software complexity happens, of course, the flaws or the vulnerabilities are also getting kind of multiplied. So what are the threat examples? So we have seen in the industry unauthorized control logic modifications. You talk about the PLC systems or a DCS, SIS, up to SIS we have seen that. So all of it is reality. Control network denial of service. Yes, we have seen some cases where maybe they have exploited like a buffer overflow or something and caused the denial of service, which is causing, ultimately loss of control, monitoring. You have seen also the HMI and operator workstations getting compromised. We have, I think, got in the use cases one case where the HMI of the water treatment facility got compromised. So all of this, what we are talking about, are the real world OT threat examples. And last but not the least is, of course, the big one, the remote access, because we see that because of the cost, because of the quick response, the remote access is increasingly being asked by the asset owners for various reasons. And then the exploit of that by those threat actors is a reality. So we talked about now some of the key concepts, risk we talked, vulnerability we talked. The last in this one is the concept of defense in depth. And I think you being all coming from the process safety management background, we talk about independent protection layer, IPL and all that. So this concept is nothing different, but this is the term which is widely used in the context of cybersecurity. So we wanted to just, emphasize on that how the defense in depth concept is one of the important concepts which has been also put under the IC 62443 standards. The logic is the same as what we know from the whether you talk about the process safety perspective, that you need to have number of protection layers, independent protection layers, and the similar thing we will going to talk about here. So this is what we see, the famous Swiss cheese model, and which is equally applicable in the case of when we are looking at the cybersecurity risk. And what we do, how we do, we are deploying multiple independent layers of protection, redundancy and diversity. Now, I must say here, unlike the case of process safety, where we have voting or we have a number of fault tolerant systems, redundancy in the case of cybersecurity not always works unless it is some sort of a physical security breach or something like that. Why? Because invariably, the redundant pair also will get compromised because of the same attack. So very few times we really come across where the redundancy, which is otherwise a very good effective control, is not so when you talk about the cybersecurity risk, barring certain scenarios where you are talking about the physical security or destruction and so on and so forth. So diversity of controls is important. So improving overall the OT system resilience with the objective finally that you want to make the system robust and minimize the process downtime because of whatever compromise, if at all, if it happens. So just as an example, if we have to take it, I wanted to take an example of preventing unauthorized software installation. Okay, so that to make the concept clear in the context of OT security, what we are talking about. So as you can see that if you are given a permission to install a software on your OT system, that could be very dangerous because that software can have malware, spyware, whatever it is, and it can do, various, scenarios one can think of giving the access to install a software on the OT system. So this is our case. Now, if I have to apply the defense in depth concept, then what should I do? So this is just an illustration of that we will be implementing what we call as role-based access control. So we talked about the role-based access. that only the required privileges will be set and given to the user. There will be role-based access, so that if you do not need, you are not going to gain access to install a program, no matter your operator or even a plant manager. Plant manager doesn't need to have that access or whatever it is. So role-based access, which will take into account two important concepts: least privilege access, that is clear from its words, the minimum access, and segregation of duties. So role-based access is based on these important philosophies. The segregation of duty is also equally important, because you do not want to have a super administrator who has been given all the accesses. So between the role of OT cybersecurity folks and the functional roles, like if you are a DCS expert, then you will have access for your ultimate whatever access you should have from an application perspective for the DCS, but not necessarily as the Windows user, okay? Because your roles have to be segregated based on that. So you will not have access for the purpose of, say, security configuration of the systems and so on. So role-based access is one of the fundamental things which you will do. Second control, what we'll use it is what we call application whitelisting. So when you have, this is a type of software which you will install on the system. And what it will do, it will basically prevent any kind of executables to be installed. So no software can get installed when you have got such type of application whitelisting installed on your machine. So no matter, even if you are an administrator, it doesn't give you the access. Why? Because it will prevent. It does certain thing in a manner which will prevent anybody, whoever has even got an administrative access, from installing that, unless you bypass that application whitelisting with some other access and all that. And last but not the least, after having this also, in case if somebody breaks that, then you must have monitoring in order to quickly correct that. So security monitoring, it will not prevent, but it will at least detect and then try to minimize the risk exposure, so that immediately something can be done. So this is just an example that how the defense in depth we need to apply for various type of risk what we will be evaluating as part of the OT cybersecurity risk assessment, which each one of them will bring in certain type of control, but all of those diverse controls we will have to consider in order to make the system resilient. So this is a pictorial representation about our concept of defense in depth. So you look at it, the organization, you look at the plant inside, at the heart of it, you have all the security threats which are coming in, and what all we apply as part of defense in depth. At the top, we have organization, security framework, policies. We talked about initially also the three pillars what we mentioned. You have to consider plant, it is, sorry. So the plant security protection, the physical security, what we have, plant security design, what we talked about, the segregation of the networks, system architecture review, all of that. Then security operation and maintenance. So we are not going to stop there. Once the plant is built, we talked about the sustainment controls, the security operations monitoring, and so on and so forth. So when you look at it broadly, the defense in depth will really comprise of technology, it will comprise of the policies and procedures, and of course the design. So again here, we'll take some example of defense in depth concept in terms of the physical security, the way we have to look at it, again, when we do the physical security assessment of the OT system. So you have to start from the very top of it, which is right on the device. So if you think about the OT device, you think about, say, for example, of a safety controller, safety PLC controller or something. It has got a physical key which is directly there installed on that. Not all the time or everyone will have, but you have it in many of the cases, some physical keys which are there on the device. So which is a ultimate security, because unless in some cases the key is not kept in certain mode, like a program or something, you will not be able to do anything. So this is one of the important physical controls. Then you are talking about the cabinets, which are all of them has to be securely locked. And not only that, the many of the organizations now, in fact, they have got unique lock and or even made accessible, only for that team of people, in order to further improve the robustness of security. Because you may be knowing that majority of the places we have retail cabinets, and those retail keys are widely available. So many of the times now the asset owners recognize that risk, and they come up with the idea of having one unique lockable key for each type of system in order to further improve on that, because otherwise you have a generic key which can be used everywhere. Then of course you are talking about the access control for the building, to the engineering room, to the rack room and all that. You have plant access, and many cases also to get to the company also you have access. So this is some concept of how we look at it for a physical security example, which is one of the important controls, by the way, for cyber security. Because what people consider it as part of the cybersecurity risk assessment is that if you are able to touch that server or something, you can consider it that you are able to have the access to do some compromise. So building this layered security for physical security is also equally important. So I think we have just got about 3 minutes over here. So uh, we can take a pause here, or we can look at it completing. I think let's do that. We'll continue for one or two more slides until we hit that. So we talked about all of this. We talked about the risk. We talked about defense in depth and all that. So the next one, what we want to do is basically how we, mitigate those risks, and what are the security controls, which are OT cyber security controls, what we adopt. So we'll have some focus on that in terms of the cyber security controls, which we will apply in order to mitigate the risk, because in most of the cases uh, you are not able to avoid it. Yeah. So what we have is that, just for the easy understanding of it, we are breaking down it into preventive controls, detective controls, corrective controls, and responsive controls. Okay. Overall, in terms of looking at it, wide different functionalities of control, what it brings. So preventive control is one of the most important ones. Of course, as the name suggests, it prevents it, right? So the controls like having antivirus, firewall, access control, patch management, those are all going to be the one which are actually actively going to prevent that particular cybersecurity event from happening, because firewall will protect, block the access, antivirus will clear the, so it's a preventive control. Are we just going to be happy with the preventive controls? No. We talked about it. In a defense in depth, you must have detective controls also. So if something goes wrong, then identification of that malicious or suspicious activity needs to be monitored or first analyzed. So you have got the security logs, you have got the intrusion detection systems, and all of those ones, log monitoring. All of those are detective controls which are equally important. In case of a compromise, if we have no visibility to that, we have still got a problem, because you don't know what's going on. Third one, again important, is corrective controls. So in case if compromise happens, you understood also, but you do not have any corrective means. Say for example, the system is compromised and you do not have reliable backups which are available. Then what's the use? How you go back again to the business? So the corrective controls, many of that really falls into the category of this backup and restore systems and all that, which are widely used in all the cyber security controls. What we keep it as part of the defense in-depth approach is a must, because they will ensure that in the event of compromise or a failure, you have the backups available, and again at a diverse location available, so that you can restore the systems. So disaster recovery plan and all that. The responsive thing is again most important. All of this is there, but you do not have a proper incident response procedures. Okay, it's not of any use. And we have seen in some of the incidences which has recently happened and which has impacted in UK a lot of, it has got multi-billion-dollar exposure and all that. And some of that is also related to the effectiveness of the incident response plan, right? So you have all the things, but then you do not have a proper response in terms of the recovery operations and all that. You do not have an incident response plan and so on. So that is another set of controls which comes as part of the incident response, disaster recovery and all that, which is important. So I think we'll have to take a break here because it's already 1 o'clock, and we'll continue with the security controls probably once we are back from the lunch. So
yes, okay, sir. We'll take the break now, and after the break, I think we have 1 or 2 questions in our chat box, so we can address also. Yeah.
Perfect. So we meet at 1:45.
Yes, sir. Just before breaking for the lunch, I would just give a recap of this attendance thing. I think the participants were facing some problem how to get their attendance marks. So I'll just give a recap, and after that we'll break for the lunch, just for 2 minutes. Yeah. Okay. I'll share my screen, sir. Yeah. So, participant, this is just if anyone of you have missed like how to get yourself registered and get your attendance mark for this webinar and to receive the certificate, I'll just give you an overview how you can do this thing. Let me just go back. Yeah. So when you open this course HSC Process Safety Academy portal link, which I'll be requesting by my team to post in the chat box, you will get an option to log in. Just a second. I'll open that page directly. Yeah. When you will log in from your this email ID and password, you will be redirected to this page. And if you are just a first-time user, you have to click on sign up. So after clicking on the sign up, you will be redirected to a registration page where you have to just fill in your basic details like first name, username, email, and password, and your contact number. So these are the only mandatory fields. The rest you can leave and get yourself registered for this course portal. So after making your account, you just have to enter your email address and your password, and then log in on this HSC Process Safety Academy candidate portal. So when you will log in, you have to click on this all one-day intensive courses complete package. So this package is having a bundle of almost 10 webinars. So yeah, you have to navigate to this particular webinar, one-day free online international webinar on cybersecurity of DCS, PLC, SCADA, and process control system. So you have to navigate to this webinar and click on this. After opening this particular webinar page, you have to upload the screenshot of the webinar you are attending. So at the start of the webinar, when you have joined or currently if you haven't taken the screenshot, just take a screenshot of the webinar that you have attended, and at the end of the webinar at around 4 p.m. we will be concluding. So at that time you have to take a screenshot of the webinar, and then you have to upload both the screenshot here. In the first one you have to click upload the screenshot at the start of the webinar, and in the second one you have to upload the screenshot which you will be taking at the end of the webinar, right? So after uploading both the images, you just have to click the submit button, submit dash update verification proofs. So you have to click on this, and when you will click here, flash message will come that the screenshots have been successfully submitted, right? So with this, you will be able to mark your attendance, and after the attendance is marked, our team will verify both the screenshots and will generate the certificates accordingly. Okay, so if anyone if you have any doubt regarding still how to mark your attendance, how to log in this particular portal, so you can just post it in the chat box, or you can reach out to us at our help desk and our WhatsApp number. The details will be posted in the chat box, right? So you can see from there also. With this, I'll break for the lunch. We'll break for the lunch. Uh, 45 minutes of a break will be there. So we will reconvene, resume the session at 13:50 Indian time, IST, right?
Yes, Ayush.
Okay. Okay, sir. We'll meet, participants will meet at 13:50. Enjoy your lunch. Thank you.
Thank you. Thank you. Okay, good afternoon once again. Welcome back. I think you have good lunch. And I'll try to keep the session engaging so that we continue with the security controls what we were talking about before the lunch. So welcome back. Uh, so we talked about basically preventive, detective, corrective, and responsive controls. And as what we talked about, they're all required to be there for its own purpose in order to build the overall resilient cybersecurity structure. So, continuing that, again, the same uh, concept, we have just explained it in a hierarchical manner so that it further, clears the way we approach the various security controls. So, this diagram actually shows from a different way, uh, depicting from the data security. So even if we consider the confidentiality is like the last priority, but still the data security is of importance, especially the data which is of what you call proprietary nature or which is the process data which is being used. So the data security at that level, we talked about the encryption technologies, some of the tools like DLP and so on. Application security, we are again talking about certain applications, what we talked about at the case study, which we took it as part of the prevention of installation of unauthorized software. We talked about applications such as whitelisting. There are many more within that: post intrusion prevention, uh, the application whitelisting, file integrity monitoring. So, variety of them are coming under the application security. Host security, which we talk about the endpoint protection, patch management, hardening. I mentioned about the system hardening earlier. So the system hardening is one of the basic controls which often we see is kind of underestimated, which should have been the focus area. You see, in many plants when you go, you find operator stations which are having games and sometimes even certain accesses for all the unwarranted things which is not supposed to be there on a OT system. So the host security is again important layer with the uh, patch management which we talked about, which is important for addressing the vulnerabilities associated with the software, especially the operating system. Building on from the host is not standalone. Host is sitting finally on some network. All the stations what we talk about there, unless the system is just a simple PC and it doesn't have any network, which is there, but mostly we find that systems are networked. They are having number of stations, number of controllers. So the network security is again very important. And what we do in that, again, similar to the system hardening, the basic control which has to be there is you have to do the network hardening. Again, at the very basic level of the network switches, we have to implement what we call network hardening so that you prohibit certain protocols from using it, disabling the ports which are not being used, and of course the access control, other things which has to be there even for those switches. Those are important consideration for building network security. Then you are talking about the advanced things within that in terms of the traffic monitoring, whether that traffic is being monitored through the applications like next generation firewalls, or we have built the systems like intrusion detection system and all that. So they all form part of the network security. But again, at the base level, as we talked about the host security, you need a system which is secure at the basic level. So you do system hardening. Likewise, for the network, we do the network hardening. So further to that, we are talking about the perimeter security, and we talked about it during the Purdue model presentation what we had, where we talked about perimeter security with the data diode, with the double firewall, and so on. Above that, which is at the again the heart of it is physical security. So the physical access control and also the monitoring accesses and other things which are has to be there. They are not good to have, but the systems, unless they are physically secured, you cannot really talk about the logical security what we are building with other controls what we mentioned. And of course, at the topmost level is the policies and procedures which drive, of course, all of these controls, and in some cases, the procedures which dictate also in a manner which certain policies are enforced, whether it is a policy of carrying the portable digital devices in the plant or restricting the movement of the people. All of that has to be dictated by the OT cybersecurity policies and the procedures. So again, from the perspective of procedures, what matters and what, again, I will not go into many procedural aspects, but some of the key ones. Which are those? So the first and foremost is the permit to work, which is often kind of underestimated when it comes to these type of systems, being many times close to the IT system. So permit to work has to be enforced in the same way as what it has been done. The change management, we will talk again in terms of the sustainment and all that. So all these procedures, in addition to that, the portable digital devices, because those are the one of the biggest risks. What are they? The laptops, what we use it for the purpose of configuration. The USB hard drives. No matter what we do, but we still need to use the USBs in our environment for various operational reasons. So all of these. In order to basically ensure the automation control systems are all secure. One aspect of it, again, which is important from a procedural aspect, is linking certain requirements to gain access on the system. So very often this is not been done, is like the case of a safety, if we take, that unless you have a permit to work training or you have taken some safety training, you do not have access in many of the organizations to the plant. So similarly, if you are going to have access to the system as a user, whatever, you may be the engineer, you may be the operator and all that. So unless the person is being trained in terms of following certain do's and don'ts of the cybersecurity, he or she should not be able to gain access for that, and that should be backed up again by the refresher training and other things, the same way as what we do for the safety has to be followed. Hello? Hello? Ayush, can you hear me? Hello? Okay.
Hello, sir. Sorry, sir. I was on mute. Please come again, sir.
Yeah, no, I got disconnected for a while, so I lost the share. Can you reshare it again?
Okay, I can definitely just share it. You can take the control.
Yeah, so the last one which we were mentioning about the procedure controls and following certain the expectations in terms of providing the access to the system should come with attending certain cybersecurity training. So that's what I was trying to emphasize before I got cut in my communication. uh, the next slide, we take little bit more details of what are those controls. So the technical controls, what we talked about, or technological controls. One of the important things what we have to consider there is the use of Active Directory. Now, this is what is the Active Directory we widely see in terms of the information security systems or a corporate IT systems in any organization, where the Windows security domain, which is built on the Active Directory, in terms of enforcing the security policies and enforcing the role-based access, Active Directory plays a very important role. Likewise, in the case of OT systems also. So all what we are talking about gets implemented through the deploying Active Directory or a security domain, just the similar way as what the IT systems they do. But in our environment, which is purpose built in terms of the role-based access, in terms of the security policies, what needs to be provided and so on. So that is one of the important control, which is providing the logical security. The next one is, of course, the firewalls. We talked about it before also, is one of the most important network control point, which we widely use in terms of complying with the expectations what we earlier talked about IC 62443. The other one is IDS systems, IPS systems. IDS stands for intrusion detection system, which are again, depending on the risk, they get deployed in order to detect any abnormality on the network early on, so that you can minimize the downtime, you can flag if there are any potential actors trying to gain access to the OT network. So intrusion detection systems are very important. Again, they cannot be applied or need not be applied everywhere. It has to be a decision based on the risk what have been identified. IPS is not something which is very widely considered within the OT environment because of the concern on the availability of the system. So what is the difference? D is only doing detection in case of intrusion detection system, whereas here it is prevention systems. So because of the concern what we have on the availability, generally in our environment in automation control systems, you don't prevent it, because the risk, if we consider it, the risk of bringing down the system because of the loss of communication or whatever it is more, in order to give priority for the availability of the system. The other ones are anti-malware. So there are, like what we have it on all our computers, at a base, you must have the anti-malware, antivirus systems, which is still we find it in some of the organizations. It's not been implemented, or if it is implemented, not been patched. So when I say patch, if you have just the antivirus installed once and it is not getting updated, it is of no use, because whatever the new threats which have been identified, vulnerabilities have been identified, the what you call indicators of compromise which have been identified will not have been updated in that patch. So anti-malware which is updated is of importance, and not just having a antivirus which is really not being of any use if it is not updated. The last one is, of course, the removable media control. So as we mentioned that in our environment, we still have a lot of use of secured, USBs. So the USBs are required in terms of copying or in terms of doing patching by the team which does the maintenance and so on and so forth, even by the functional roles that someone wants to copy something and take it the configuration or whatever. So the use of removable media has to be still controlled, and make sure that how only the whitelisted, or when we say whitelisted, that means the approved USBs are in use and which are properly getting scanned every time before the use. So every time the USB is being used, we have to make sure that it is being used only by the authorized people, which can be done through the technical control. And also the device itself is being whitelisted. That means no personal USBs or anything which should be able to be plugged in. And in before it is allowed to be plugged in, again there are variety of other technological controls which we can put in order to make sure that they are scanned without relying only upon the antivirus which is being installed as part of the host security. So again, we talk about the defense in depth approach, where you have multiple controls which take care about minimizing the risk coming out of the use of removable media, which is mainly, you can say, USBs. Administrative controls, many of that we just talked about a while, uh, and permit to work, media device. The last one, again, we must have a proper procedure in terms of the disposal methodology. So we talked about that life cycle uh, for the cyber security, and the last one which we mentioned was, of course, the demolition, the destruction. So the procedures have to be there by the asset owners or the other stakeholders in terms of how securely we can dispose of the components of the systems when they are being phased out. Physical control systems, we talked about CCTV surveillance and all that is gaining, of course, for the newer sites, this has been there. Biometric access controls. So all of that is there, but the key point also is in terms of what we talked about earlier, physical security, the guards. So the security guards have to be there and they have to be trained in terms of doing the verification in terms of what type of devices by frisking that the personnel are carrying inside the plant area. This is very important because these days the miniature things they can basically bring in and which will go unnoticed. Some of them may be having some wireless connections. Some of them may have certain other malware and other things which is plantable after they gain access. So even though you may have the surveillance by the access card and all that, it's very important that when you gain access to the plant sites, they need to be told in terms of verification of this digital devices what are allowed to be carried, and if somebody is taking it, they are being cross-checked against the use of only the company approved devices are being taken. So that is very important because if they are not tied into all these procedures, including the permit to work, there is a potential for the malware to get basically transported through the use of all of these type of what we call portable digital devices and gaining access into the uh, key locations like the engineering rooms or wherever the OT systems are installed. So this slide is just to give you flavor. Some of this we have talked about. We talked about application whitelisting. This is, in my opinion, one of the most important control, technical or a technological control, which we should consider it within the OT environment because it prevents the basic what you call the risk in terms of having any kind of executable run on the system. So it's a very powerful control and it is not as much used in the IT side because of the various operational considerations it may have. But within the OT side, the application whitelisting has to be considered when we do our risk assessment and all that as one of the important preventive controls in order to block execution of any kind of additional unapproved programs which may carry the malware, spyware and all that. Network security, intrusion detection, we mentioned about that. What it does, basically intrusion detection has got variety of features and depending on the technology what is being used. But it basically checks the traffic what is going on and any kind of abnormality which can be both, which can be based on the baseline. So there are certain techniques which are based on the neural networks and all that. They will try to identify any connections which are getting established, or some communication which was never seen before. So those can be, you can consider it like behavioral based, which is a drift from the normal baseline, or they can be more deterministic, like signature based. So both of these type of techniques are utilized by the intrusion detection systems in immediately flag any kind of anomalies which can be potentially immediately attended in order to minimize the extent of the compromise. Again, we can't generalize the use of IDS because again there is a cost involved. So depending on the risk, depending on the type of security mitigation capability we intend to have, these will deployed or not deployed. Secure remote access. So we mentioned about the previous slides, because of the various reasons, including the OEM requirements, the asset owner requirements of establishing, quick support from the vendors, various reasons, cost. The secure remote access is required by the OEMs, even sometimes by the company personnel only who are probably away. So meeting those expectations by having certain software which can ensure security of the connection, because these connections are, you can say, internet connections, or in some kind sometimes the lease connections and all that, but at the end of the day you have to treat it as basically unsecured unless we deploy certain software tools in order to make it compliant with the expectations again which have been put forward in the IEC 62443 standards in terms of what type of security we should have for this remote access, which is very important. We talked about data diode as one of the most important perimeter protection, and within also, because it inherently avoids the transfer of communication coming in from the, you call, non-trusted end. So in our case, like in OT, you will treat the IT as a non-trusted or untrusted zone, and you will treat ours as the trusted zone. So you will block basically any kind of that communication. Again, this has to be risk assessed and applied. Portable digital device control, we mentioned just now, and in that connection, the USB scanning has to be there, and in order to really ensure that every time the USBs are utilized, they are properly scanned. Because one of the biggest vulnerabilities is the USBs, because they can be totally uncontrolled and they can bring in a lot of risk by way of having certain thing implanted on that, and which can then proliferate once you have access and installed it. And we'll talk about that also in the case studies, that in some cases how that particular thing got propagated, because once you have got that in the environment, the spread of that is by exploiting some other vulnerabilities, you will be able to spread that. Backup and restore, that was the corrective control we talked about, and is one of the very important control which will be always considered as part of the system design. So what is it doing? Of course, as we know, that it will automate the process of taking the backups with whatever as per the expectations what we have, and they can be programmed, and it will be also utilized in order to restore the systems from those backups which are taken. So it is one of the most important control which needs to be considered as part of the design. Again, when we talk about the restoration, we have to make sure that we have to do those type of testings once in a while to make sure that whatever we have backed up is actually the integrity of that is good enough and we are able to restore it. Active Directory, we talked about before, is one of the most important thing for the logical access control in terms of implementing role-based access, in terms of implementing security policies and all that. And along with that is the Radius server, which is taking care of the network devices. While the Active Directory is taking care of the Windows devices, the network access, that is basically you are talking about the switches, the firewall, these are all called network components. Those are properly being controlled, logically authenticated and all that by the use of Radius servers. So these are some of the controls. And last but not the least, at the bottom, what we call it is SIE.
So that is security incident event management. Okay, so we talked about before that IT systems have been using this SIM, which is basically collecting the security logs from entire network devices, from your computers, from the servers and all that. And somebody does monitoring of that 24/7 in terms of detecting what is going on. So the same thing is also now getting gaining traction in terms of utilization of that within the OT systems, where they may be combining these two or they may be keeping separate depending on various considerations what organization may have. But the 24/7 monitoring of the OT systems in the same way as the IT systems have been done is also one of the important controls, and which is also many of the times been required to meet certain expectations which you talk about in terms of higher security levels. Similar to like we talked about the safety integrity level, we have security integrity level, security levels. So higher the one what we go, certain expectation in terms of the monitoring would be required. And the control like SIM, which is a system where all the logs will get aggregated and will be available for monitoring with the correlation and all that will be made available. So logical access controls, again, we just want to give a kind of a brief on that. We talked about role-based access matrix, which is an important thing in order to make sure that we do not give too many privileges for the user beyond what he or she needs to have. We talked about it. So this is one of the most important logical access control. The other one which was lacking previously quite a lot, now the maturity is building. So establish individual accountability. So same way as what we have accounts on our own PCs for your organization, you log in with your password, username and all that. In the same way that in the OT side also, we have to establish the individual accountability. We have to avoid any shared passwords, which is meaning that you have a shared accounts and so on. We have to remove all the default users. All of these form part of the building very robust logical access control. The last two things which are mentioned there are also important and which are again implemented as part of the security policy, where you provide auto logout and auto log off. We all know that even in our organizations, when you are away, after a while the station will get locked. In our case also, in some cases, when the applications, engineering applications and all that are very important, it is very important to auto log off completely, so that in order to really avoid any kind of unauthorized access because of that. Password management, again, one of the most important control which will get delivered as part of the security policy implementation. So the complexity of the password, changing of the password, all of those policies will be getting driven as part of the Active Directory, and the users will have to really follow that. Why? Again, we want to minimize the potential of unauthorized access, and all these components, they are important foundation for that. ACS user access approval process. So this is one of the big thing what we see in many of the brownfield plants. What we see here when we go for the assessment is that there is no proper record of who has got the access to the system. So you talk about say DCS system or a safety system and all that. So there has to be a process within the organization where somebody prepares the application, somebody approves the access with the condition of certain trainings and all that, and it is getting tracked. What I mean by tracked is that all the users who have got access will be kind of put into the user approval register list or something like that, and they will be tracked as part of what we are talking about there of periodic access reviews and all that. So there are two processes which will go hand in hand. So first is giving the access and making sure only the required resources are being given access who are fulfilling certain prerequisite in order to give them the access. And second one is that what we see there down the line, periodic access reviews. So it's not just that you have given it, but periodically you are reviewing it. Who has got the access? Who doesn't need the access? Because this is also equally important. The people who have left, probably their account still exists, and they can be again very vulnerable if it is exploited. So the access review is again one of the process which will make sure that the people who no longer need that, their accesses can be removed. Least privileged access we talked about before only with the role based, so that's why I'm just skipping it. The last one, the two, which is again which is part of making the system robust for the unauthorized access. So one of the things which is sometimes considered as also is having a buddy system. So for a very critical thing, you are actually required to collaborate with two people in order to put the split passwords into the one. And this is being used sometimes also for critical safety systems and all that, where the concern of act of sabotage or something would be there, and that time two people have to collaborate in order to make sure that the actual changes in the program when they have been done and deployed, two people have been involved, and to make sure that they work like a buddy and the passwords get split. So unless they both put the right passwords, you won't get the access. So this is like a higher level of authentication in terms of the critical things what you do, and which is also being used in the industry. The other one, this is a buddy one, which is a different, where you are talking about the two resources, so it gives a totally a different type of a control. Whereas multi-factor authentication, we all know, even some our IT systems, sometimes you are having multi-factor authentication, you have some OTP coming in, or you get certain other biometric scanning and other things. So password and that. So those are also required as per certain expectations by the policies, again driven by the risk, where you have privilege access, and in order to make sure that the potential for unauthorized access is minimized, you basically specify in your policies and procedures the use of two-factor authentication or multi-factor authentication for those systems or applications. So to summarize, the basic cybersecurity controls, what we talked about, have to be really implemented, before we go for some advanced technologies and all that. Because many a times what we see is that the basic things are not being done, and we are talking about 24/7 monitoring by the SOC, implement SIM and intrusion detection system, while the basic controls are not in place. And as we say basic, we talked about before, the system hardening is not being done, network hardening is not being done, networks are not segregated. None of these things have been done, which are essential for secure by design. And we implement, carry out certain advanced things which are good to have. Of course, it is required by the risk, you have to implement it, but not without doing all these basic controls. Uh, so those are the type of things what we talked about, again are just summarized there. You talk about system architecture, you talk about anti-malware, individual accountability, removable media control, no remote access and external connections by default. As we said, the policy should state that by default, nobody will be able to establish this type of connections. So only by approval, and when we say approval, that means the organization expects you to carry out a proper risk assessment, and only then you provide the approval in order to establish, because these really have a big security impact when you establish any remote connections and external connections. Last but not the least, after having all that, detective controls are important, and that's why the audit policies and security logs have to be there, no matter what type of controls you have implemented, because this is the control what will help us to track what went wrong when you are doing any kind of incident investigation. So this is the summary of the cybersecurity controls, what we have, and the variety of logical, preventive, defensive, corrective controls which should be there and which should be weighted by or been recommended from the risk assessment, depending on the type of risk scenarios the automation control system or the environment really poses. So after the controls, now we talk about managing OT security process overview, and we'll talk about 4 important things which we should really look at it, which are important in order to maintain, the cyber security. We are not talking about all of them. We just picked up the key stuff or what I thought it is important for this webinar. So that gives the expectations from the standards that what minimum things have to be there, and the organization must support it. So before we go that, there is our observation that many of the organizations in India, they think about penetration testing as an ultimate, the process. We have seen that they expect that if the penetration testing has been done, then we are secure, and then they really do not consider whatever we talked about before in terms of having this basic controls and other things. So this is one of the biggest myths we have seen, that the organization has done pen testing, and then many of the times all the other things what we are talking about in this circle are not being there, including the risk assessment and all that. And we'll consider that why these are important. Similar thing is also about the vulnerability management, and we'll understand that why these things are really important as part of the managing the OT samples. So the first is, of course, the risk assessment we talked about before, that it is similar to what we call it like for the HAZOP or a SIL assessments and all that. So the only big difference is, of course, here it is completely qualitative. We are not doing any kind of a quantitative risk assessment generally for the cyber security risk assessments. And as we talked about, we are talking about understanding the consequences, understanding the probability, and then utilize basically if there is a corporate risk matrix to translate that into the risk ranking or evaluation. And how we do that, we mentioned before. So identification of the vulnerabilities, we start, and when we start with that, we are looking at all what is there in that particular system or a network or whatever we talk about, and then identify the vulnerabilities for each of the device what it has. Then we are talking about the threats, threat actors, events, circumstances which can exploit it. And then similar to HAZOP, like we do a what if and all that, the multidisciplinary team basically comes up with the scenarios. So all what we do is a scenario based evaluation or assessment of the scenarios, looking at the vulnerabilities, looking at the possibility of how the threats can be exploited, vulnerabilities can be exploited, and then coming up with a proper credible risk scenario, which first we will understand what is the initial risk or what we call as an unmitigated risk. So similar to some other things what we do in case of some other risk assessments, we come up first with the unmitigated risk. So that time we are not really looking at whether the application whitelisting is there or the malware is anti-malware is there. None of those things are there. So purely to understand what is the unmitigated risk, we do not take into account any controls and come up with that. So that gives us the worst case scenario of a particular vulnerability associated and what is the unmitigated risk for that. And which we do, by the way, for all of these controls when we do the detailed automation control system risk assessment. Once we do that, then of course we are conducting what you call mitigated risk assessment, where you take into account whatever controls which you are thought of as part of your expectations, and or in some cases brownfield which are already in place, and then consider that okay, what is the risk, what is there after we look at that, and then depending on the type of mitigated risk as per the corporate risk matrix, if that is not falling under the acceptable risk criteria, we need to look at it and try to minimize it following the same principles as what we normally do as low as reasonably practicable. So we have to adopt to the same thing to consider that whether the risk can be further reduced. Again, for many of the systems, we still find that the risk may not come to the low, and you will have to consider in terms of documenting and accepting that risk by the system owner. But the process will follow basically where the mitigated risk will be analyzed. If there is a possibility to further reduce that, we will further add the controls to see that the risk is kind of reduced to the acceptable level. So as we said, this is just a workflow of what we talked about. We do it as a multidisciplinary team exercise where all the people, which is basically like operations, the functional engineer for a control automation, maybe the DCS engineer, the OT cyber security engineers, all of them, they come together, they look at the vulnerabilities, they develop the scenarios and they analyze it, they identify the initial risk, then they look at the mitigated risk, and then they continue the risk assessment. So this is just, I put some of the consequences and other things which is coming in from the RAM. Most of the organizations, they have their RAM, and we try to keep the process consistent. So that is one of the important things, because all the risk for the plant, including cyber risk, have to be assessed at the same level or with the same what you call measures. Otherwise, you do not have equivalence in terms of what risk you talk about from a process safety or what you talk about the cyber security. Ultimately, it should have the same basis, and that's why it is important that the RAM should be consistently followed, whether we do the cyber security assessment or not. But it should follow the same thing. We should come up with the same risk ranking following the company RAM. Probability is one thing. Initially, if you remember, when we started our discussion, we said that it is one of the challenge in the case of performing risk assessment within our cyber security systems. Why? We will talk about that. But the case here, what we want to see is that normally every organization has got the RAM and then the probability they have mentioned with certain nodes and all that. Now, because of the uniqueness of the cybersecurity events or vulnerabilities, and the probabilities are also, you need to have certain considerations on in terms of applying certain nodes what you sometimes have it from the organization in terms of determining the probability. Why? Is because unlike some of the other cases, the variability of the systems, the vulnerabilities, exploit potential is very unique. So the team has to decide, and that is why in many organizations there is a room given by the the loss prevention or the authorities who basically manage the RAM and other things, in terms of giving some sort of flexibility for the assessing team to slightly deviate on the probability, not strictly following certain things, because if you do that, then probably you may underestimate the risk because certain things has not happened. But we have to differentiate that those scenarios are very unique from a cyber perspective, and even if it might not have happened in the company's history, there is a good amount of potential it can happen. So some amount of understanding has to be there on the part in order to be flexible to apply certain norms which are otherwise very rigidly followed for rest of the assessments. But here the considerations are slightly different because of the uniqueness of these scenarios which are coming in from the vulnerabilities which are continuously changing, and the exploits which is highly undeterministic in that manner. So we'll talk about that. So this is just an example. Again, just to be consistent, we use the same way as what any other. So we talked about this. So in the case when we are doing some SIL assessments or you are doing some LOPA or whatever it is, we are having very good foundation in terms of having the instrument, equipment failures and all that. They are very well documented and all that, which is not the case when we talk about the cyber security events. The vulnerabilities, the exploits, the threat actors, all of that is such unique. So in order to come up with the probability determination is a very challenging thing. Although you may take certain things into consideration about the industry experience and all that. So dynamic nature of vulnerabilities and exploit potential is a very unique thing, which is very specific for that particular asset or for that particular what we call system under consideration. So to come up with a proper credible event with a proper determination of probability is very important, and especially it gets very challenging when you are dealing with what we call high consequence low probability scenarios. Now we are talking about certain scenarios which you may take it like the one what we will discuss in the use cases, which is the scenario which not scenario, the incident which happened on the Ryconic safety controller. You must have heard that, which happened I think 2017, where there was a specific exploit, compromise of the safety controller which happened. Now if you think of that, that one is a very high consequence scenario where you are talking about the compromise of the safety system. So to come up with the risk of such type of things, where you talk about high impact, low probability, is very, very crucial and critical. That how do you manage that? And you come up with so that you don't underestimate certain risks just because of the fact that the probability of that could be low. So managing probability in the cybersecurity risk assessment is one of the unique thing, and which requires certain skills, some judgment, and a good multidisciplinary discussion which has to come up and forming basis of that, so that you don't underestimate the risk. Most of the times it is because of the probability which could be taken as low, you might be actually underestimating the risk. So this is one important thing which has to be kept in mind when we do the risk assessment. So here I just put certain things what we see, and then when you try to see the analogous to that, anything on the cyber side, you will never have anything like that. The pressure transmitter failure rate, you will not have some failure rate or compromise rate for a virus to be there. You will not have, because it is so much specific and there are so many considerations to that. So all of this is so well documented, and we can firmly consider the failures and all that, which is not the case in the cybersecurity risk assessment because of the very nature of it. Here also again the equipment failures are so very, very nicely documented, which we can take full credit of when we do our assessment, whereas you will not have any kind of such type of information about the cybersecurity failures. And even if they are there, there are so many things because of the secrecy, confidentiality and all that, there is a limit to that. And again, to rationalize it into your environment is also one of the things. The uniqueness of that could be again very extremely challenging to understand, that what is their architecture was and so on. So basically because of such type of constraints, doing the cybersecurity OT risk assessment, these are the challenges which the team has to understand, appreciate, and then do a good assessment of it to come up with a proper qualitative assessment of the risk. So once we have done the risk assessment and you have identified it, of course, in the risk treatment you are looking at it as what we initially talked about also, mitigating it, because most of the times you are really not able to avoid the risk, which is the case in all our type of risk what we deal with in the plant. You may not be able to avoid it, but you are mostly mitigating it. Yes, you may be able to avoid certain cyber exposures depending on certain things. Suppose if you are talking about uh, the risk coming in out of the external connections, and you decide, no, I don't want to have, I shall not have any external, I shall not have any remote. Yes, you will probably be able to avoid the risk of that external or remote connection. But again, depending on the considerations, you may not be able to avoid that because that external interface may be required for certain things, which is like, regulatory expectations of communicating maybe the SENS data or whatever. I'm just sharing, some potential, showstoppers which could avoid, uh, for the organization to strictly adhere to that no external connections allowed, period. So, because of such things, what we deal with is basically mitigating it. So, whatever we talked about, all these controls are mainly in order to reduce the probability of that by building whatever multiple controls, defense index, and all that. Transferring the risk, yes, which has got a restricted thing which comes into play where you're talking about certain risk about the patching and other things and all that you probably give it, you transfer the responsibility to OEM and this and all that. So to certain extent, you are able to do the transfer where you involve that your, maintenance service providers or whatever in terms of carrying out those things, and to certain extent trying to transfer the risk as a asset owner only. The last and most important, I would say, in all of this is acceptance of the risk, and which is many of the times the big issue what we are seeing. That we talk about the cyber security, we talk about risk and all that, but most of the times, most of the organizations we seen, they have never done any risk assessment. So if you have not done even the risk assessment, having the type of visibility and clarity to the asset owner definitely is not there. So there are two aspects of it. One is that the risk assessment is not done, he's completely not knowing what the risks are. And the second one is that the risk assessment is done, but then the the owner of the asset or a system owner or an asset owner doesn't have the visibility in terms of understanding that okay, what are the risks. So this is one of the very important gap what we see, that lack of communication by the people who do the risk assessments do not really get communicated well to the ultimate authority which owns the risk. So acceptance of the risk is very important. So the first line we talked about, there is a big, misconcept what people carry, that the penetration testing is ultimate, and we have done it. We don't do risk assessment, so which is really a big, I would say, misunderstanding, and that needs to be clarified. Risk assessment is the most important OT process, I would say, which is also expected by the IEC 62443 standard in terms of identification of the risk, which becomes your foundation in terms of building your system or whatever it is. And pen testing is not. So penetration testing validates the exploitability, okay, of the whatever the the vulnerabilities and all that are there, but it is not at the cost of not doing the risk assessment. So the last bullet, what it says, pen testing does not replace the risk assessment. So this is the big takeaway that people have seen. They understand it in a different manner. So somebody did some pen testing, they gave some certification that yeah, I have done the pen testing, found nothing, whatever it is, and then they have never done the risk assessment. They have not give the visibility to the asset owner in terms of what risk they have and all that. So this is really not acceptable as per the standards also. So to summarize, what are the common pitfalls what we have seen in OT risk management? First and foremost, no ownership. Why it comes? Because again, there are no proper roles and responsibilities defined. So who does what in terms of the risk is not clear. Treating cyber separate from the operations, many times they consider it, oh, this is cyber security. Many times the
it is looked at it with the IT risk and all that, which is really should not be the case. They should just look at the cyber OT risk as any other plant risk, follow the same process, follow the same risk evaluation criteria we talked about before. High impact, low likelihood scenarios, big thing, because you would probably very much undervalue the risk what you have. If these things are been not, just because of the fact that this has not happened and you consider that scenario to be a highly unlikely or something. Whereas if you look at it from a consequence perspective, it's a huge scenario that it could lead probably to the fatalities, catastrophic, destruction, and so on and so forth. So that is the misjudgment. Ignoring legacy constraints. Okay, so this is another important thing. You do the risk assessment and all that, left it. The legacy aspects, what have been brought newly to that, because the systems have not been patched or whatever, they are never been addressed. So those are again not getting reflected in the risk assessment because of the legacy considerations, which is again a big gap. No formal risk acceptance, like I mentioned, into the acceptance of the risk. We have seen many times somebody did the risk assessment and all that, but there is no formal record of system owner accepting it, that this is what he or she accepts at the end of the day as a residual risk. And the last and the probably to conclude, there is no review cycle. They think that I have done it once and good enough, we have done it. So there is no process which requires them. So similar to what we do, a PHA, which is done periodically. The risk assessment, again, based on the risk what has been identified, should be there in a company procedure that you have to repeat it depending on the risk every 3 year, 5 year, whatever it is. Or whenever the circumstances which are getting changed, in the sense that when the system is upgraded, again, you must do that because it's a new equipment. It brings in new vulnerabilities, new architecture, whatever it is. So it should have, the policies and procedure should dictate that periodic risk assessment or triggered by certain ad hoc conditions, which probably change the overall risk evaluation. So we need to consider and address all these things so as to avoid any pitfalls from the risk assessment or risk management process, which is one of the most important process, I would say, on which the whole OT cybersecurity program is based on. So probably we can take that later. We had just put it, but I think we have the break coming in at 3 o'clock. So we have 10 minutes. So probably we can skip that and go to the. So after the risk assessment, the other important process which I would like to share with you here is the vulnerability management, and we talked about it during the initial few slides in the morning. We talked about what is vulnerability, what are the OT vulnerabilities and all that. So OT vulnerability management is again very important. Why? Because you have seen, unless you have identified the vulnerabilities, all of this is of no use. So it is all a risk-based approach, and risk-based approach starts from identification of the vulnerabilities and tracking it. It's not one-time exercise. So what is happening is that the challenges what we face in the OT, even though some of these are, vulnerability management is a common process, very well established on the IT side. But what differs between the two are some of the things which are mentioned here in the challenges. So in case of OT, we have diverse systems. Unlike, in IT, you have one system or maybe two, there is a SAP and this. But overall, well, if you look at it, they do not have such type of diversity as we have on our side. You have hundreds of systems in the plant. Whether analyzer, this, that, PLCs, DCS, so many components, so many things. So diverse systems, not just diverse systems, they are distributed. Some of them are network, some of them are standalone, some of them have legacy issues, some of them are already obsolete. So all of this brings in unique challenges
to the OT as we try to manage those vulnerabilities. So which are quite a lot different than the way the IT side folks would be doing it. What differs furthermore is that on the IT side, there is a lot of automation. So the whole process of vulnerability identification and taking corrective actions, everything is workflow based. There are automated tools, centralized tools, and all that. So very effectively on IT sides, the vulnerabilities are managed and systems are patched, addressed, workflows are there, and all that. So that type of automation is not existent on the OT side for various reasons, including the biggest reason is the availability of the systems, which we talk about. So that prevents it from doing it, and also the type of assessment what we need to do as go no go decision making in order to do some patching or not is entirely different than what we normally do on the IT side. So what are the key things that on a continuous basis the vulnerabilities needs to be tracked? That means they should be collected. When we say vulnerability, they normally come as security advisories or alerts from the OEMs or from the CERT. CERT is the organizations which, the every nation has got that. Or some of them also come, we'll talk about in the other slide, from certain organizations like they used to have ICS and US CERT, now they call it CISA, Critical Infrastructure Agency. So they also, publish the security advisories which are, collected. So unless and until we keep track of that, we will not be able to have understanding about what are the changes which are happening in our environment and which are posing risk. So once we have that, we have to assess the applicability of that. Okay. So even if there is a particular advisory for the same component what you have it in your environment, the impact of that needs to be assessed for you to clearly understand what is the risk. Maybe you do nothing is good enough for you, because the manner in which that device or a system is being used or programmed will not be really able to give the threat actor, exploit potential in order to do exploit of that vulnerability. Many examples are there. Many of the times, all the switches and other things have got no external connectivity and all that. So many of the things which they talk about may not be applicable in our environment because the way that particular switch or a router has been used also. So understanding the impact is the second thing of the process. You first collect it, there is a process, you understand the impact, then you execute the action. Depending on, again, there is a vulnerability, not necessarily all the time the vendor might be coming with a patch immediately. So either you have the execution where you can patch it, where there is a patch given in order to address that flaws, or the organization will have to consider what are the compensatory controls which can be applied in the interim. Because I do not have the patch, but the vulnerability exists, the exploit potential is there. So how can I survive? So all of that is done as part of that evaluation and understanding what are the compensatory controls which are there. So this slide is actually giving a good overview about how we do the vulnerability management, how the organizations must do that, and they should keep doing it as a process all the time. And the basic of that starts from the asset inventory. So as I mentioned in the risk assessment also, we are trying to understand vulnerabilities related to the every piece of equipment what is there on the network or on the system. So having a proper asset inventory is a very, very important fundamental thing. Asset inventory means what? What all you have? Switches, firewalls, controllers, workstations, everything. So all of that has to be there, because unless you have that, you will not be able to track the vulnerabilities associated with each of that. So vulnerability identification is the second one. As I mentioned before, doing the risk assessment of that that, okay, this is a vulnerability. So this is not the full-fledged risk assessment I talked about before. This is a specific localized risk assessment, what the organization must do, that certain thing is being popped up by the security advisory. Okay, what is the impact on that? Yes, we'll set up, we'll understand, we'll do some risk assessment, we'll see the applicability of that, and then based on that, we'll do the mitigation plan. Whether the patching needs to be done or nothing is required to be done, do nothing, or patching to be done, but after some time you schedule it. In the interim, you do that. So all of that process has to happen here. And then, of course, you are doing the verification, and then it's a continuous monitoring. So you have done the patch, you have implemented it. So this is a continuous process. And in order to sustain the cyber security of our environment, of our plant processes, this is an essential thing which needs to be done all the time. So how we do that? As I mentioned, we do it most of the times as a manual thing. You collect the advisories from OEM, national certs, CISA and all that. Or in some cases where certain tools have been deployed, say some of the systems which have got the intrusion detection systems, they also have this feature of providing the vulnerability report. So in those cases, this can be automated, but not always. So depending on whether the systems have got certain this type of functionality implemented, you may get automated vulnerability alerts and all that specific to your environment. Otherwise, you are setting it up manually, you are collecting it and analyzing it. So the key considerations overall, to sum up, OT vulnerability management is risk driven, not patch driven. This is a big difference between IT and OT. They will do the patching immediately, whereas in our case, we'll have to look at it, do the go no go decision in order to do what based on your circumstances. Asset inventory is foundational. If you don't have that, then you don't know what you have. So what advisories you can track if you don't know first of all what all my system has. So safety and availability comes first. So it's not the case that you get the patch and you just deploy it because of the availability. We'll have to look at it depending on again what is the risk of continuing it. You have to take a call. Not all vulnerabilities require patching. Very important one. Maybe many of them, they are not really applicable to you, and you will just record it, do nothing, evaluate it. But this should be done as part of the process. Compensating controls are critical because during the interim time when there is no patch, you must make sure that the vulnerability is not exploited because there is no patch. Continuous monitoring is mandatory. So at the end of the day, you have to keep doing this process all the time in order to make sure we have the full visibility of the emerging vulnerabilities which the system is experiencing or which is exploitable. So we have done now risk assessment, we have done the vulnerability management. The last one, important one in this is of course the incident response, because as we said, you build a system, everything done, but you have to think always and prepare that my system might get compromised, and then how do I respond it? So no matter what fantastic controls you have implemented, you have excellent robust security system architecture, you have to still consider my system will get compromised, and that's why you must have properly documented incident response plan. And that incident response plan typically will have all of these type of phases clearly described, that what is the preparation, how you detect it, because it is very important also to understand in OT side how you detect this compromise. Many times it is not so clear. You may think it is a hardware failure, you may think it is a mechanical failure, but it may not be the case. So detection of this cyber security incident is very important. How you spot that? Then of course you have to respond. So how do you isolate the systems? Again, it has to be a very well documented procedure. If something is wrong, you detect it as a cyber incident. How you respond to that? What immediately you start isolating? people should not think at that time that, okay, how am I going to respond? No. Here is a procedure, here I follow, this way I will do it, this way I will isolate the systems. So all of that should get documented in the incident response very clearly. Then of course you have a phase for doing the analysis, because before we restore the systems, you must understand what went wrong. Otherwise, the recovered system again will experience the same thing. So doing that as part of your incident response may or may not be all the time 100% completed when you restore the systems, but it's an important part of it. Then of course the recovery, you must have a documented process how you recover those systems, you restore the systems. And then last but not the least is lesson learned. Very, very important, because the actual incident gives you the real life, that what worked, what did not work and all that. So the lesson learned session after any kind of incident or a near miss is very important in order to reflect on the policies, procedures, controls what we have. So requirements for that is you must have an incident reporting and handling system similar to the safety reporting and all that. People should be able to report that somebody is there in the system in order to evaluate that and all that, and then of course manage the active incidents which are happening at site. So in terms of responding to it. The last one is of course the requirements is to have, we must conduct incident response drills. Very, very important. There is a big finding from some of the big incidents that the people were not really capable of reacting to such type of things. Although the procedure were there, they had never practiced it. They were never been having a refresher training for it. So overall, if you think of it, the preparedness level was not there in order to respond it effectively, and that caused the major delays and all that. So this is one of the important thing where we must organization conduct certain drills and do the periodic refresher testing and training and all that. So the key takeaways is, for OT incident response, you must, similar to safety, we must promote the cyber incident reporting. We must integrate the cyber response with the enterprise incident response. It should not be kept isolated, because at the end of the day, you're talking about some emergency response. Conduct periodic training for incident response team, very, very important. Every organization must have some annual refresher training for that. Conduct periodic incident response drills. Again, various different methodologies can be adopted, not necessarily to do the full blown every year. Then conduct the lesson learned for continuous improvement. So to conclude, no system can be designed 100% secure. We know that. Same within the safety also. So risk is mitigated and not avoided. So we are not talking about building a system which is 100% secure, no need of incident response. No. The question should not be facility should be compromised, but when. So you prepare for the ultimate, worst case scenario where something has gone wrong, so that the procedures and other things, incident response plan will make sure that you restore back, and which is giving kind of an assurance to the management that with all of this, we will be able to minimize the downtime in case if we are compromised. So this is one of the most important aspect of the overall incident response. I think it is already 3 o'clock, so Ayush, we take the break now and then resume for the next sections.
Sure. So we can take a 10-minute break now.
Yeah, because 5 minutes already I am late, so but I think it is better to take a break here and then continue at 3:20.
Yeah, we can reconvene at 3:20. Yeah, that will be good.
Thank you.
Okay.
We'll,
Thank you, participants. We'll reconvene at 3:20. Just stay tuned with us.
Good afternoon again. Can we start with the last session before we conclude, hopefully on time, 4 o'clock?
Yes, I think we can continue.
Yeah. So let me continue with the remaining section. So we talked about incident response plan and how it is important and so on in the last session. The last process within that, we covered risk assessment, we covered vulnerability management, we covered the incident response plan for the OT, and the last one is we want to talk about now the operation and maintenance, or from that aspect, like the sustainment of the overall cybersecurity in this section. So, what are the sustainment? I mean, we all know that in the plant, for every discipline, there are some plant maintenance, preventive maintenance program, what is being done, whether rotating, electrical, whatever, instrumentation, each have got their PM program. So, in order to sustain the cybersecurity, we should have also the preventive maintenance program for the OT cybersecurity, and that should get integrated with whatever SAP, ERP, PM modules what we have in terms of the reliability centric maintenance. So many times we see that although we have all the maintenance for the control automation systems, but this piece is not kind of integrated, and they are managed in a different manner. So a formal preventive maintenance program has to be developed and then put it together with the rest of the discipline PMs in the SAP. So what we talk about here is the some basic sustainment activities which must be done. I mean, for each side there could be some addition, deletions and all that, but the idea here is to consider that what needs to be looked at it as a periodic preventive maintenance in order to ensure the sustainment of the controls what we have implemented. So what we are talking about is 6 at least the sustainment activities. The first one is we mentioned before also, operating system patching. So we know that Microsoft is always releasing every week the patches, and IT systems they do that. But in our environment, like we said, our systems are required to be available. It is not easy to do the type of patching the way we do it on the IT side. Nevertheless, there has to be a preventive maintenance strategy where you perform the patching with whatever frequency which is acceptable to the organization and linked in the PM program. Same thing goes with the antivirus. They are some of the manufacturers, they are bringing it every day, every week, or whatever it is. It may or may not be practicable to do that, but depending on the risk, one has to consider a preventive program to do the antivirus patching periodically. Let it be week or a month, whatever. It cannot be more than that, because if that antivirus is not patched, then we are having a big risk exposure actually of all those unmitigated indications of compromise or the vulnerabilities what we have experienced. So this is essential that this has to be again linked with the PM program and carried out. The third one is the backup and restore. We again talked about it as a corrective control earlier, but the sustainment of that is important because the changes do happen and they need to be backed up reliably and tested also in terms of restoration. So both the backup as well as restore activity has to be programmed as part of the preventive maintenance program, so as to make sure that whenever the system has to be restored, we are fully prepared. The backups are there, and not just there, but their integrity is verified so that they are available for restoration when we require or on demand. The other one is access reviews. These two we have talked about before, but this needs to be again put as part of the PM program, because it's very important that we have a control on the users, and not just the control, but you evaluate the continued privileges what you are giving to he or she as a formal process of conducting the user access review, say per year or whatever, or 6 months. It's important because it's a process which is definitely one of the important mitigating control, and they need to be as part of the program maintenance. The last one is again, audit policy reviews and all that. So depending on again an organization whether they don't have the continuous monitoring, there has to be some focus on looking at the audit policy logs just to make sure there are no kind of near misses or any potential activities which have happened, not potential, actual activities, but then only they will get reflected in the audit logs. So these are the ones which are just suggestive in terms of what the basic sustainment activities which can be considered. As I mentioned, there can be addition, deletion to that, but these are the recommended ones based on the importance it carries in terms of managing the vulnerabilities or having the backups and all that. What other things needs to be there besides what we talked about, the programmatic preventive maintenance? Integration of OT cybersecurity controls with operations procedures. Again, when we were dealing with before the procedural controls and all that, we touched upon it. So physical security has to be there all the time in terms of doing this risking for portable devices and all that. It's a very important sustainment control which has to happen all the time. Training, the periodic refresher training, the first time training for the users or the operators and all of that, depending again on their role. So on a continuous basis, the training has to be given, and no OT training, no access. These type of things what we typically see in case of safety. You don't have the H2S training, you don't have the PGW, you can't have the permit to work, or you will deny access if you do not have that. So such type of things has to be done on a continuous basis. The third is very important, is procurement language. So there are many aspects which are written in your contracts or a procurement things and all that, which deals with quality, which deals with safety and all that. But the cyber security aspects is many times missing. So there has to be a procurement language related to what the contract may be about the cyber security. So which should cover overall, how the cyber security aspects for both OT as well as the data security and all that has to be managed, and that should be reflected as a procurement language in the contracts or whatever we do with the vendors, with the third-party providers and all that, or the maintenance providers, or all of it. It's very important that unless the treatment is given in the same way, like for the safety and all that, the cybersecurity compliance cannot be considered as granted because it's not reflecting in your procurement language. Permit to work we talked about before. Many organizations still have not linked certain important aspects of tying the permit to work with the tools which are basically linked with those which are used with the automation system and all that. So in order to restrict the use of only the approved laptops or approved USBs and all that, they need to get reflected in the PTW process itself, so that then only you have a good, robust administrative control. Otherwise, it's a weak control if you are just said only use approved USBs and you do nothing in terms of verification of that. So when you have it kind of tied up with that, there is a process which will take care in terms of filling the required thing. Okay, what is the model number of the laptop, tag number of the laptop, when this was last certified, when it was scanned, and so on and so forth. Very, very important. So that it will make sure that only authorized laptops which are again been tested for its scanning and all that are in use when people are performing their work. Last one we talked about, I think will not repeat. Uh, it's important that destruction also has to be done in a proper manner so that there is no loss of confidentiality because of the data what was residing on those systems. So these are the things which have to be considered as part of the sustainment. So to sum it up as key takeaways, for the sustainment of cybersecurity in organization, we must have OT cybersecurity competency assurance program, which makes sure that the people are trained and they are being refresher training and other things are part of the assurance program so that they can deal with all what we are talking from the OT cybersecurity as a user or operator or whatever. Cybersecurity landscape and technologies change is constant. We know how we are evolving. Now, in fact, there will be further tremendous exposure to the AI-based things which are also started coming in our environment, so which are going to make the things even more challenging. The things like where we are talking about not just the smart plant from the engineering perspective, but also smart plant from a control perspective, which is also increasing the risk surface and all that tremendously. So unless you are securing those systems, you will not be able to really manage or secure those assets. So you can't say no to the technologies, but how do we really make sure that those technologies are secured and the plant operations, integrity and other things are maintained, availability. Management of change, we all do that as part of any changes what we do in the plant, but many times those MOCs are not done in the same way when it comes to the changes onto the OT cybersecurity. Again, there are some gaps which we have seen, which are not really, we should not have such type of gaps because they can lead to some serious issues or potential risk if they were not been properly validated. Will it be a change in the firewall configuration rule or some changes into the some configuration settings? So all of that has to be strictly followed by the management of change so that they are evaluated and implemented. Last one is the one which is sometimes we tell our customers to integrate also is periodic review of security configurations. Okay, so with the passage of time, what we call sometimes as an operational drift, we see the configuration settings have been changed because whatever changes are happening and all that, not that it's a mechanical drift, but just because multiple projects, multiple things have been happening and all that, and in that process there might be unintended changes which has happened. So somewhere those things have to be revisited, especially when it comes to the hardening and other things where the program action as a preventive maintenance program can be put for the periodic review of that. So this is what is mainly we wanted to highlight as part of the sustainment of the cybersecurity control, what needs to be done in order to make sure that the controls what we have built, designed, built, and then put it into operation continue to remain in place and overall the systems and processes are secured. So I'll skip this discussion for now as we continue with the last part of this our session. So we are going to talk about some OT case studies and some observations what I have seen in my last 10-15 years of journey into the OT cybersecurity. So we'll start first sharing, the typical gaps. Some of them we have already talked about as part of the discussion, but just still a repeat of it in terms of, giving you the importance what it carries, because these are widely being seen in many assessments what we do. So the basics again are what we are finding are not there. So many plants so far, unless they have been built with the evolution of IC 62443 and all that, they continue to have issues with the network segregation. There is no segregation properly done with IT and OT. Very weak controls are put. We are still having many plants, especially in, when you talk about the manufacturing assembly lines and all that, have very, very flat network with no segregation with IT. A big concern. Architectures, they are not been designed with the concept of what we talked about, perimeter security, DMZ and all that. They don't have. Many organizations only relied upon the switch and all that without really having a proper what you call network control in the form of a firewall or something. So that makes it weaker for having a very secured architecture interface and all that what we mentioned before as security zone, conduits and so on. So the use of properly evaluated network control point and the policies of those firewalls and other things are missing many times. Third one is, again, there is a widespread use of these remote connections which are given to the vendors and sometimes also to the company staff, which is absolutely not having any security. They use certain, open source or open available software which are not having licenses, nothing, and then the connections are established to the plant directly, so which is very, very risky. So remote connections are unsecured many times, and the biggest thing what we have seen is external connections sometimes are not even known. So sometimes some external connection at the time of plant commissioning was an expectation from the utility operator or whatever, or a government regulation, like we said about the emission monitoring or whatever it is. Electrical also, there are sometimes, you have got certain external connections with the distribution company, but then they are never been really tracked. And with the passage of time, people even forget that okay, they had certain external connections to the systems. So the big finding comes when we do sometimes the walk-in audits and all that. We cover that there are in fact external connections which are not known. So from the security configurations standpoint, the gaps what we have encountered is the shared account. The systems are not hardened, which like what we talked about is a basic control. Patch management is not done. The patches which are being there for the last 8-10 years when the system was installed is the last and final patch. Endpoint protection in many assets, many organizations, the systems do not have antivirus also, which is a basic thing. They do not have the control for managing the USBs. On the IT side, yes, but not on here. So those are the type of big risk because of the removable media. That means you are able to get anything accidentally or intentionally onto your system. Network hardening, similar to system hardening, again we have seen that the organization doesn't have a proper hardening procedure in order to harden the network, and that's why it even doesn't get implemented. From the policies and procedures, as we talked about before, many organizations they have IT policy and they try to do something within that for OT, but we should have actually OT a separate treatment, and then the OT security policy shall be really well established, which should become as a mother document to drive all the procedures and other things which are required. Key OT processes, like there is no process of asset inventory management, so we don't know what we have, and we discover sometimes when something happens or when we do some walkthrough on that. So big gap in terms of not having that properly documented inventory, properly documented or functional vulnerability management, incident management, and all that, what we talked previously. So at least there has to be a process. It need not be, automated or anything like that, but something which tells that, okay, I need to gather this advisory, somebody has to review it and all that. So some basic stuff, even though it can be manual, but that has to be there. Same thing goes with the incident management plan. OT risk management, biggest thing. Hardly anywhere we see that the organizations have got the properly documented OT risk assessments. Very, very, very few. And which is really, one of the most fundamental thing we talked about, also expectation from IC 6443. They have never performed, so there is no visibility of risk for the asset owners, and which is really very, very concerning that there is no risk assessment and lack of visibility and understanding. The last is, of course, roles and responsibilities, because the OT cybersecurity and other things which comes with that, they are not still really got integrated. So the clarity in terms of the role and responsibility as a system owner, as a system custodian, as the user, and all that is not well defined, and that makes it more challenging because those roles have not been identified, and then there is no question of getting communicated or somebody being held responsible as or accountable for that. So this was the observation part. Now we will talk about certain case studies, near miss or actual incidents, and I took up those ones which had got the key consequences or potential key risk, I would say, considering the participants mainly come from the background of process safety management and all that, so it becomes more relevant. So 4 of them which I wanted to share here. I think most of you have heard about Stuxnet because it's been talked about for a long time now. That was the first time that Iranian nuclear enrichment centrifuge, there was a destruction, and known cyber weapon which was utilized for physical damage and all that. That was way back in 2010. So that probably the first initial attack which can be considered as OT cyber attack. Then I picked up one. I mean, there are numerous ones, but the one I picked up again, as I said, I wanted to have something representative. The Ukraine power grid, which happened in 2015-16, which impacted electrical distribution, and which was again a kind of very concerning thing because that could really cut off the power distribution. And I mean, if you look at it from a different angle, here the impact was probably limited to whatever, but you consider the similar thing which was probably happening during the war time and all that. So the risk what it could cause when you talk about the power grid failures. The third one we mentioned early in the morning again for an unauthorized access. When we took that example, I mentioned that we'll have some use case coming. So this was one incident in 2021. This is some water treatment plant in the US, and that attacker could gain access to the HMI, which is what we talked about, L2 network, and then he could change certain settings for dosing, which caused sodium hydroxide, from 100 ppm or whatever to 11,000. So in this case, again, it was like a act of sabotage. You can say this was, I think, what we remember was the employee was fired, but his credentials were still active, and then he could gain access and did this remotely. So again, it has got a key consequence, same controls and other things what we have talked about were really not been there. And the last one is the most concerning, probably, which changed again the way we look at it, the cybersecurity when it comes to the safety. And really, probably since 2017, I mean, a lot has changed because the although this became like a near miss because there was no actual safety incidents which has happened, but the intention which was there behind was clearly to cause some catastrophe in terms of having destruction and then loss of containment and all that, because they were trying to build the malware in a manner which will defeat the safety functions so that they are not available on demand when you need it. Unfortunately, or fortunately, unfortunately for them, fortunately for the operator, it got triggered in a different manner. There was a plant shutdown only, which happened many times, and the months went in until it was discovered that it was not a hardware or other failure, but rather it was a part of the very well organized advanced cyber attack. So this was the significance that it impacted the safety controller. It was the first malware which directly impacted the safety systems and so on. So which really was very concerning, and we'll take a little deep dive into that and what happened there in the next slide. So purposely I called it like a near miss. Yes, it was an incident. You can say yes, there was many shutdowns and all that, but near miss I am just putting from a manner because it did not cause the she incident, which was really the expectation of the attackers. So it designed to target the Triconix controller, which is a very well documented safety system and being used so many places. First known attack we talked about. So what was the mechanism in which this happened? So I thought it is important for us to understand that. So what happens looks like that the attacker initially breached the IT network and they went into the OT. So again you see, and this has been the case also in some of the other incidents which have happened in UK, and which was also having something to do with the lateral movement from the IT. So establish access to the engineering workstation for the, which we call TriStation, which is the engineering workstation for the Triconix. Once the engineering station was compromised, they tried to install, which was a kind of a legitimate file name, Trilog, onto that TriStation, which is the most, I would say, interesting part of the whole thing, because the way they actually got it as part of the legitimate file. Then the exploitation of the TriStation protocol. So the malware impersonated legitimate TriStation software and then it communicated with the controller, safety controller, directly. And what they did, the malware read and modified the memory of Triconix controller, and because of that, they could get access to the control logics. They could manipulate that. The only thing is that while doing that, they were able to do that, but there was probably some bug within the malware that did not cause that aspect, but it just caused the shutdown. But you see the way they have entered and then they have moved it laterally, gain access to the engineering station, and then try to show it as a legitimate software and try to establish communication to the controller. Very, very advanced mechanism. So what was the lesson learned from that incident, which I think is very important for us because being a safety system. So I mentioned about that physical key switch earlier on when we talked about the defense in depth, and that is one of the most important thing which was not normally being followed in many organizations. They used to keep this key into program mode or a remote mode instead of the run mode for various reasons. But then that was one of the big findings, that this key should be always kept in run mode so that you are building basic controls. What we should also consider is the role-based access for the safety system. So the access which is provided, again, we talked about the buddy system and all that. For the actual logic download and all that needs to be reviewed and can be considered with all of these type of things, that two people and all that, so that you, again, this particular scenario was slightly different. You may not be have been able, because they have already gained the access in other manner. But this I am listing it as some of the controls which should be there in the safety systems, especially when it comes to the safety controller logic downloads and all that. Network segmentation, definitely we talk about strict air gapping and all that. Here they could get their path from the IT to the OT and to the safety controller, so you can understand what type of considerations it could have probably. AWS monitoring, inspecting and restricting the network communication to authorized engineering consoles only, which is definitely one thing, so that you map only those MAC addresses or IPs and all that. Integrity auditing. So periodically we have to do the checking, verification of the logic changes and the versions what they have, and keeping track of that. So what has been going on. So as you know, all these safety controllers, the changes they are tracked. So the version changes every time you have got some changes. And the last and important, we have to keep it in mind whenever we are doing the risk assessment, system architectural reviews and all that, that we have considered this safety system in our HAZOP, in our SIL studies and all that. And we need to consider the worst case scenarios also of these cyber security attacks, and probably look at the pathways which could offer the secondary means of degeneration. So you imagine the safety controller is already compromised. So how do you still achieve that? So this is something which needs to be looked at. So overall, from the major incidences which we have seen, including many incidents which has happened into the automotive sector and all that. So these are some of the lessons learned. What we can sum up: the procedural lessons learned, implementing a comprehensive cyber resilient framework. We talked about IT/OT environment, regular risk assessment, look at the act of sabotage scenarios. Technical lessons learned: robust IT/OT segmentation, strengthen logical access control. We mentioned that all of these have been identified as some of the findings in those lessons learned. Restrict remote connections by default, security log monitoring, detection of potential compromised accounts, advanced endpoint protection. We mentioned about various controls earlier on. So some of them were lacking in certain cases. Network anomaly detection, which is provided by IDS and all that. So at least you identify something wrong going on early. And of course, the operational lesson learned, which is again, the management of the portable digital devices, and then some of the enhanced control for the safety system, including like what we talked about, potentially having a buddy system and so on, so that you really have a very robust control on the program changes and all that. So these are some of the lessons learned which we try to summarize it from some of the major incidences which have happened within OT. So we come to the conclusion of this webinar, and these are some of the final takeaways and summary which I would like to present. So to summarize, we are not now in a mode where we can think of it that okay, let's do the ICS OT cybersecurity as a good to have or something. It is no more the fact, because of all the things what we talked about, from the adoption of the technologies, adoption of the commercial of the shell, so many things. So it's not just good to have, it has to be now part of the whole thing. Safety cannot be achieved without the security. So you have seen that the Tricon controller was there, everything is there, but if it is compromised, you can't assure the safety, you can't take the credit for that safety function what has been managed because of the cyber security concerns. So we should really manage at an organization level automation control system cyber security similar to the way we manage safety, so that the whole process of management is brought at the same level. What we have seen is that with recent wars and the geopolitical landscapes and all that, the critical infrastructure of the nation must be secured, and OT cyber security again cannot be really looked at it in a casual manner, because it can have tremendous impact, especially when at the time of when these tensions arise. So identification of a risk is must. So we call it, that is why the risk assessments and all that has to be there. We can't protect what we don't know. So lack of visibility of the risk is one of the important, not important, it is one of the major concerns. And we need to identify and then reduce those risks to what we normally do as low as reasonably practicable. So at the end, managing automation, control, cyber security is required to sustain process safety and reliability. OT system user, what we talked about, giving him training and all that at various levels, whether it is operator or the engineer or whatever it is a primary layer of protection. So we need to train and empower him. We must bring, similar to the safety, cultural change in the organization to look at the cyber security awareness by conducting training, quizzes, bulletins, and all that. So as we are building that culture of cyber security, we must have a very good established OT cyber security governance program, so that all these policies, procedures, and actions are really well directed. And of course, the last and but not the least is engagement of the senior most management. And I think in most of the organization, the OT cyber security is now really going to that level where it has to be, where it has to come from the top, recognizing the risk what it poses to the organization. At the end, we should not treat OT cyber security as a project. Many times this is a mistake what we see, that okay, let us run an OT cyber security project. No, it is not a project. You may have certain projects in order to implement certain things and all that, but we must consider this as a continuous process and manage the OT cyber security in a sustainable manner all throughout the life cycle. So if you are really interested in knowing something more about that, I mean, some of these organizations which give OT cyber security training, which is kind of industry oriented and practical, and not merely to give an overview of the standards and these one. So more fit as a practical, what you call functional training in terms of OT cyber security. You may be interested, you may talk to them. So at the end of the day, I mean, I would like to thank you for really attending this, and I hope you are able to, you have some takeaways from this, and thank you so much.
Thank you, sir. Thank you very much for giving this wonderful session. To all the participants, with this, we came to the end of our webinar, this one day international webinar. Please do take away the ending screenshots for the webinar and upload it on the candidate portal link, as I have guided you in the lunch break and the break earlier to the lunch. So you can upload the screenshot there, and our team will verify the screenshot, and certificates will be issued after the verification. And on the behalf of HSE Process Safety Academy, I once again thank you, sir, for delivering this wonderful session, and all the participants for being with us to learn from this session. And also, we'll be starting the registrations very soon for our 90-hour as of course, EHA leadership course. that you can also join. And please stay connected with us. Join our YouTube community and WhatsApp community also for receiving regular updates. Uh, we'll meet again next month for the PSN implementation webinar, which will be delivered by Mr. Sarvesh Sharma. So thank you, and I'll take your leave.
Thank you so much, everyone.
Thank you, sir. And participants, one more thing, the questions that have been posted here in the Q&A session and also in the chat box, we will record a video of that answers for the answers of those questions, and we'll release it on our YouTube so that later you can refer your answers to those queries. Thank you. Participants, there is a link posted in the chat box for the review. This is a feedback review link. Please do click on that review link and provide us your valuable feedback for this webinar.